Hello everyone, welcome back to the channel. So this is the next part for your airline booking system project, right? We have already uploaded a couple of parts on the airline booking system, which is a microservices driven Node.js based backend engineering project. This project is going to help you understand how exactly you can maintain multiple microservices, how you can write as clean as possible, kind of like a code, how different interesting problems come in a transactional systems and whatnot. This is kind of like the I would say project that was part of our earlier lambda iterations, which is our advanced backend development course, right? This was one of the most loved projects among the students, and we were getting a lot of requests to actually put this on YouTube. So here we are, this is the next part. And before you actually start watching this particular video, two important things. First, I would highly recommend you guys to watch the complete project videos end to end, so that you have a very nice looking project in your portfolio. Second, we have launched our next iteration of Lambda, which is the Lambda 4.0 Advanced Ultimate Backend Development course, which is kind of like bigger and better this time, right? This is our course where we are going to go with a TypeScript first approach with a lot of interesting projects. You can see we are going to make something like a code sandbox project, on demand movie streaming app, live streaming app, Telegram bots, social media app backend, booking.com based I would say hotel booking backend, url shortener projects, slack like chat applications, video calling app, crm app, lead code like backend and whatnot. This is one of the most power packed courses that we have launched. You can go to the course website, I'll put everything in the description section below, and you can also use the coupon code backend so that you don't have to pay this price. The prices are going to slash off, right? And I would highly recommend you guys to first of all go through the course syllabus that is already put in here. It's going to be a TypeScript first approach based course. We are going to also talk about low level design patterns, a lot of interesting design patterns in TypeScript, and we are going to use those patterns in our projects, right? We have also introduced an introductory module on Golang and how you can write some backend services in Go. A lot of interesting backend concepts and a lot of advanced database concepts are also there. Again, as I'm saying, this is going to be your one-stop solution if you want to become a backend engineer. If you are at any level, SD1, 2 or beyond levels, this is going to be a very interesting course for you, so that you can add a lot of interesting projects in your portfolio. So what are you waiting for? Check out the link in the description section below, use the coupon code backend and get massive discounts on this particular course. And let's head back to our project video and let's complete the airline booking project. Now let's add a few more things here, right? The first very basic thing that I can see that I should add is that, let me remove this console.log. Okay. Now you can see that this airplane service is calling the create airplane function, right? Which is taking a model number and capacity from the request body. Now, what if the user doesn't send this model number and capacity in the request? What will happen? Let's see how we are handling things in the code. Okay. So I'll go to this and I'll do npm run dev. Okay, so we are up, and I'll open Postman. Now, if you will carefully see that, let's say in this request, when we are creating airplanes, I don't send, let's say, capacity. Let's see what happens. If you send it, it created the airplane successfully. Why? Because we have put the capacity value as default 0. So it will not throw an error for capacity. But if you don't send model number and you send it, you can see it still created a corresponding airplane. Now that's not that good, right? Let's go to our models and let's see here. Can you see we have a default value here as well? We should not put a default value for a model number anyway, right? We should never have a model number with default value. Okay. So now let's try to create it again. The server must restart itself automatically. You can see this. And if we send it again, now you can see we are getting a 500 internal server error. Now that's very problematic. Why? Because I believe everyone knows about the status codes in HTTP request. So let me bring in the MDN article on HTTP status codes. Okay. And if you go here, then there are dedicated response code for every type of a problem. right? And technically, if you will just directly send 500, this can actually cause problems, right? So what we need to do is we need to actually send correct response codes in every case. But here, why the response code 500 is coming, right? Why the response code 500 is coming? Because what happens is you bring the request to the controller. This request.model number is undefined. This calls the service. Service does nothing much, but just directly send it to the repository layer. In the repository layer, you actually try to call your model, right? You try to call your model here, and boom, then it actually blasts because you try to call the sequelize create function and you're sending an undefined property. You can't actually make that, right? So technically, the issue is not on our server. Our server is actually working well. Why? Because the user sent a wrong piece of information. That is, user sent the data without the model number. That is actually problematic, right? So technically, this lies in the category of client error responses and technically bad request. The server cannot or will not process the request due to something that is perceived to be a client error. For example, malformed request syntax, invalid request message framing, deceptive request routing, etc. So that's a bad request, right? So we technically need to handle this as a bad request. For example, if user is sending this, we should not get 500 internal server error. We should technically get 400 bad requests. This is something that we should get. And in order to handle that, we can actually validate this request inside a middleware. So currently you don't have any middleware. You can create a new file. You can say airplane middlewares.js. Okay. And then you can write a function const. You can just say function validate create request. It will have the access to the request object, response object, and the next middleware, right? And you will say that if request.body dot model number, if inside your request body you are not sending model number, because let's say something else can happen also. For example, you want this model number to be camel case, but by mistake they are sending it like this, like snake case, for example. By mistake they're sending model number like this. Now this is problematic, right? Your code is not configured for snake case based syntax, so you should exactly get this particular key, that is model number, in this particular form only. If you don't get it, then actually you can do something, and that is let's require status codes, require from http status codes, and you can actually say return res dot status. Okay, you can say status codes dot bad request dot json. Okay, and let's see inside our controller. Let's go to the controller. You can see these are the parameters that we are sending, right? So for failure, let's send this. I'll copy paste it from here. You can see we are sending success false. Something went wrong while creating the plane, error, and you can send the error details actually. So you can send something like explanation like this, right? And you can say model number not found in the incoming request in the correct form. Okay, model number not found in the incoming request in the correct form, right? This can be the error that you can send. But let's say they sent the model number properly without any fail. Then what will you do? You will call the next middleware. As simple as that. You will just call the next middleware. So if model number is present, then we don't have a problem. I will call the next middleware. And who will be the next middleware? The controller will be the next middleware, right? But we need to actually register this order, right? Where we will register this order? So in airplane routes, currently what happens if you call slash, you're just directly going to create airplane. Now let's do one thing. Here we can actually chain one middleware. Let's do that. So from here, I'll say module.exports validate create request. Here I'll say airplane middleware require um, not dot slash airplane middlewares, right? Not a semicolon. And in the routes, just bring in one thing, const require dot slash middlewares. Okay, and we are going to get airplane middlewares, right? Let's make it middlewares plural. Okay, middlewares. And now we are going to just register our middleware. So let's do it like this. You can actually do router.post, and you can actually do something like this. So you can say airplane middlewares dot validate create request, something like this, right? Let's keep it in the same line. Okay. So now whenever you will come to this request, you will first of all validate your request and then you will create the airplane. Let's see if the server started itself. Yes, server started itself. And I can remove this console.log. This serves no purpose anymore. Okay. Now let's try the request again. If you send the request, this time everything got created. Okay. But if you don't send the model number and send the request, you can see success false. And the most important thing is 400 bad requests. Now we are actually telling the client that, okay, there was no mistake on my end. There is something that you have not done correctly on your end. And that's the meaning. This error is actually also explaining that model number was not found in the incoming request in the correct form. This is going to be something that is going to be very useful. Every time your error handling mechanism should be as clean as possible. You should be able to signify your client that what went wrong because of which their was not completed, instead of just saying that, okay, something went wrong. Currently, if you will see whatever we did with the middleware, it's pretty straightforward, right? It's pretty straightforward. But just think about for a moment. Currently, what will happen? What will happen if you have more properties that are not present in the request body, right? So you will say that, okay, I will again return this res.status.json. Okay. But one thing I don't like in this whole coding implementation is that every time almost a similar JSON we have to actually prepare, right? We have to always almost prepare a similar JSON. Like it always says success false, data is empty. The only thing that changes is message and the error part. Can I say that? Right. So we can technically actually have a response object and an error response object. And we can always throw that error response object and just configure our error property and this message property. This is something that we can actually do, right? Also, this middleware, currently it is sending a custom object, right? I believe instead of sending a custom object, there should be some dedicated error object that we should send, right? Otherwise, it will make things a bit more inconsistent because we are just sending plain JavaScript objects. Maybe we can make a error class, and that's something that we can actually do, right? So let's try to do that. Let's try to do that. I'll have a error class with us. Now it's going to be a common class. So what I'll do, I'll go to utils. I'll create a new folder, errors. So, right. And inside errors, I'll create a new file, app error.js. Okay. What I'll do is I'll prepare a app error class, right? that's going to extend. There's an error class in JavaScript, right? So let me show you. There is a error class in JS, right? So what you can see is that there is this error class of JavaScript, right? You can actually extend this class in order to make your own custom error class. You can see the error object can also be used as a base object for user defined exceptions. So we can technically define our own class that will be more consistent, and every time when the user will get an error, they will get a consistent error. This is my agenda. I don't want that for, like, let's say there are 5 interns working on one project. Everyone will start throwing their own type of error object, right? It will make things very inconsistent. And throwing the plain JavaScript object also doesn't make a lot of sense, right? We should technically throw an error object, and we can actually make a class that will make things more consistent and help us to actually standardize stuff. So now let's try to clean up things after writing our app error class. So I have written a new class app error.js inside a errors folder inside the utils folder, because again, it's going to be common. It's going to be used by a lot of other code files. I'll write a constructor, right? This constructor is actually going to take a message and a status code. Okay. Then first of all, what we are going to do, we are going to call the super constructor with the message. That is the constructor of the error class with the message. Then we'll write a property status code is equals to status code, right? Then we are going to say, uh, let's say we have our message, right? We have our status code, and we will say this dot explanation is equals to message. That is what actually happened with the current call is going to be in detail written inside this explanation. Now you can actually pass a string or do a bunch of stuff with it. So whatever information we will be sending to the client, we will actually store that inside this explanation part, right? Cool. So this looks good to me. I'll do module.exports app. Okay, I'll do module.export app. Now there is a function in the error class called as capture stack trace. Okay, so capture so capture stack trace. Okay, a non-standard V8 function that creates the stack property on the error instance. So in case if you want to also see that what's the error stack, what's the stack of functions where actually the error had happened, you can actually also store that or print that, right? But for the timing, I'm not keeping it, but just wanted to inform that you can also use that error stack or for a logging purpose or anything, right? Okay, this is good. This is good. Now what I'll do is I'll make one more folder, common, right? I'll make a new file, error response.js, and I'll say const error is equals to, I'll make a custom JavaScript object that we will be using a lot of time. Success false, message, generally the message is going to be what? Something went wrong, right? The data property will be empty, and for the time being, error property will also be empty. Okay, the error property will also be empty. And I can just do module.exports error. Okay, then what I can do is I can create another file, success response.js, and I'll copy most of the things from here. We'll say successfully completed the request, right? This is a default message. Again, you can actually change it very easily. It should be success, success should be true, right? Success. And we are going to create a index.js file. We'll say module.exports error response is require error response, success response is require success response. Okay, So we are not doing much. We are just storing the error and the success response object separately, right? And now we will be just directly using it everywhere. Okay. So let's start with our middleware. So currently here you can see we are making this whole object, right? I don't want to make this whole object. So what I'll do is I'll say const require inside utils will require common and will require the error response. We can say error response dot message. If you want to customize the message, you can customize it here, right? And error response dot error is equals to this object. For the timing, I'll return that app error as well, but for the timing, let's keep it like this. And now you don't need to just always send this. You will just say error response. So this part looks more clean now. And whatever error configuration we have to make, we are actually making it here, right? Let's try it. Let's try it if things are working for us. So server is already up. Let's try to not send model number. If you send it, you can see we are still getting the correct answer, right? So everywhere we are going to clean it up like this. If you go to airplane controller, we'll do something similar. Const require utils slash common, and I'm going to say success response, error response, right? And then again, this part we can also clean up. So you can say success response directly, you can return here, and you can say success response dot data is equals to airplane. As simple as that. So you can see it's a bit more clean now, and here as well, right? So you can say error response dot error is equals to error, and just send it for the time being. Okay, you can see the overall class already looks a bit more clean, right? Because now we are not sending that raw JSON from everywhere. It doesn't make a lot of sense, right? Now let's try to create a plane. If we send it, it says something went wrong, right? So let's see why it's sending us the error. Let's just quickly check this. Let's see, something went wrong in CRUD repo. Oh, sorry, my bad. I guess in the CRUD repo, we have not rectified our mistake. This should be create. Okay, let's send it again. And you can see we are successfully getting everything, right? And this implementation definitely looks more clean, right? Where we are just having a success response and error response, and we are just configuring that response. Every time configuring the same plain object doesn't make a lot of sense, right? So this was one cleanup that I wanted to do. Now, after this, I'm going to use this app error class that we have prepared and try to write meaningful errors, starting from the repository layer, then service layer, and then the controller. Now, let's try to use this app error object. So let's go one by one. First of all, let's go to the CRUD repo. Okay. Now you'll see everywhere in the CRUD repository, we are doing try catch, and inside that try catch, we are actually throwing the error again. Why we actually threw the error again? So that every time if the error occurs, we are able to actually log on what situation the error actually occurred, right? That was the agenda behind my thought of sending try catch everywhere, and once you catch it, you log something like this, and then you throw the error again, and then you throw the error again to the upper layer. But technically, all of this can be very easily done using the error dot capture stack trace, right? So if you actually go for error dot capture stack trace, this actually helps you to do that, right? This is going to put the whole stack trace in front of you, right? So you can see you can actually do error dot capture stack trace, right? You can actually do this, right? So let's try to do it. Let's try to actually implement or actually try to use one thing. So for the timing, I'll remove this try catch I'll remove this try catch. Okay, you can see it looks a bit more clean because we'll handle it anyhow. So we're gonna handle it. Okay, so I've removed the try catch from the create call. Okay, now what will happen? If you try to create a model, it is going to throw an error. It is going to throw an error. Looks fine. Okay. Then this error is going to go back to services. Now inside services, you can see I have wrapped it in a bunch of try catch, right? I have wrapped it in a bunch of try catch. Now, what actually we can do is, based on what response we got from the CRUD repository, we can actually configure a app error directly here. Okay, so let me do one thing. For the time being, I'll do console.log error. I'll do console.log error. Okay, let's see what error actually comes up in case the repository layer throws something. So something like this, create. Okay, now repository layer will actually throw the error. If you send it again, you can see currently we are getting something went wrong. And if you see the terminal, you can see it's printing type error, that this model.create is not a function, right? Now, what we can do is we can actually see, right? Every error object that you are actually seeing in JavaScript has this specific name. For example, type error, right? Or similar kind of these errors are there. So type error, right? You can see there is a dedicated type error that exists. Type error objects represents an error when an operation could not be performed, right? Similar to this, there are other errors as well. Type error is also a subclass of error. So technically, when JavaScript throws error in front of you, it's a custom error class, type error, that they are sending, right? And similar to this custom error class, we have also prepared our app error class. So similar kind of a use case we can have. And you can see here you are getting the whole stack trace. If you actually print the type error object, then you're actually getting the whole stack trace as well. And you can see in the stack trace, it represents most of the thing that you called create plane from the controller. It's already mentioning it, right? We don't have to specifically mention it. Then post that it is calling create plane inside the service. Post that it is calling repository, and here it is failing in the CRUD repository. It's actually failing. So this stack trace is going to be helpful. We don't need to log at specific places every time, and instead we can actually use this stack, right? So let's do one thing here. If something went wrong, what I'm going to do is I'll say if error dot, there is a name property that exists, name is equals to type error, right? If error dot name is equals to type error, then what we're going to do is we are going to send a custom error at the front end, because we always want consistent error messaging on our final API response, right? So what we're going to do is we can actually throw a new app error. So you can see it already just required it. We can actually throw an app error. Now we have to send a message. If you see the app error, we have to send a message and a status code. Okay, so where is the service? Here it is. Okay, so let's send a message that cannot, let's use the same messaging in the type error. Cannot create a new airplane object. This is going to be the message, and the status code that we are going to send, is going to be something like this. So const status codes is equals to require HTTP status codes, and we will say status codes dot internal server error. Okay, we are going to send this object that if in case we got a type error, that means internally there was something that was not going well, and that's why we are getting this error. You will feel like, sir, why you are specifically doing it for type error? Can there be more errors that can be significant? Yes. There are errors like validation error also that you can get. And for validation error, maybe just saying that cannot create a new airplane object will not be sufficient, right? So let's do this. Let's do this. So now we are throwing this app error object, right? Let's keep this throw error from here also. I'll show you how can you actually remove it. So now your repository is getting called. Inside the repository, if any issue comes up, you are going to catch it here. If the error name is type error, you are going to just throw it. Now, if you go to the controller, now you can see we are already getting an error. Now, what should be the status code? What should be the status code? Currently, I am by default just hard coding my status code. I should not hard code my status code, right? The error object has a status code property. You can say error dot status code, because that status code we are already setting inside the new app error, right? So we don't need to do that logical handling here. Service will already tell us that, okay, there was a server related problem. I'm sending you the status code, just embed that status code. And whatever is your error response, just embed that error response. That's it, right? Let's try. The server is up again. Let's send it. And you can see now we have a consistent error messaging that status code is 500. Explanation is something like this. 500 internal server error. Now you might be feeling, okay, sir, why you have done if error dot name is equals to type error? Let me show you. So let's rectify our repository. Let's rectify our repository. Okay. Let's go to model. Let's go to model.js. Right. Now you can see inside models, here you can see this is going to be an integer. Capacity is always expected to be an integer, right? Let's see what will happen if I send capacity like this. If I send a random string in the capacity, let's see what happens with our server. It blew up, right? And it crashed. You can see. So it was not able to actually insert it. See, it was not able to actually insert it, right? Okay. Now, let's see what is the error that we are getting. So if you go to services, I'll say console.log error. Okay, let's see what error we are getting. Send it again, it will blow up again. And now you can see from where the server restarted, you can see we are just getting a custom error. And this time the name of the error is SQLized database error. So this is a specific SQLized error that you are getting, that SQLize is actually not able to process it, right? So in case you get this kind of error also, then also you can actually send this app error and everything, right? Okay. Let me show you one more case. Even if you send a small string, for example, let's say HB, let's restart HB. You can see you'll get a similar kind of a use case here, that incorrect integer value, right? Incorrect integer value. Again, you will get the SQLized database error. Now let's do one thing. If you go to SQLized documentation, SQLized models, okay, you can actually put these kind of validations, right? For example, type, allow, null, and everything. So let's see all the validations that I can put. If you go to validation and constraints, this section, you can see there are a lot of validations that you can put. Allowing or disallowing null values, right? There are some other validators. So let's do something like this. Let's see, is credit card max. Let's put a min max value. That let's say if somebody has to send a capacity, the capacity can be maximum 1000. There cannot be any plane with more than 1000 capacity. Okay. There cannot be any airplane with more than 1000 capacity. The server restarted. Now let's say if you send the capacity as 1200 and you send it, you can see it's still creating. Okay, I guess I know why it's still creating, because we have to make changes to the database, right? We have made a change to the database, right? So let me just do one thing. Let me just do one thing. So I'll open MySQL. Okay, MySQL. Okay, so now you can see we did a database level change. So technically, we should either add a migration, right, and then actually make this change. But for just faster purpose, I'm going to do something like this. Show databases. Okay, because migration related discussion we are going to do separately. I guess flights is our database. Use flights, show tables. Okay, now what we're going to do is drop database flights. I'm going to drop the whole database. Okay, we drop the database. We can very easily get it back. How? Go inside the source folder and I'll say npx sequelize db migrate. The moment I'll do db migrate, uh, one second, unknown database flights. One second. Sorry, db create. First of all, we have to do db create. And before that, I'll do one more thing. Inside my migration also, I'll say capacity can be maximum object. Okay. So let's do database create first and then we will do migrate. So db create and then we'll do db migrate. Okay. Technically, if we are making any database level change, we should have added another migration. But just to make keep things simple and focus on that error messaging part, I'm doing this. db migrate. Now you can see we have a table. We will be having another table. Use flights, show tables. Now you can see we have some tables. Okay. Now let's try to make a request from Postman. If you send it, now you can see again we got an error, right? Oh, sorry. This time the server is not working. That's why we got the error. If you send it, okay, it's still creating it. It's still creating it. Let me see why. Let me see why. So technically, I was missing this validate object. That's why it was not validating. Right. If you have to add custom validations, you should not put it directly like this. You should add something like this. Validate. And now you can add the validations. Max object. This was something that I was missing. I'll add the same here as well. Okay. And now I'll just quickly drop the DB again. Okay. And I'll reset everything. Create. Migrate. Okay. Let's start the server. npm run dev. Okay. Let's send it now. Now you can see again we are getting an error. This time you will get this validation error. Now, if you get a validation error, then again technically it's something that's not coming correctly from the client. Can I say that? Right? If you get a validation error, that means the data that the client is sending is not proper, right? And this validation check cannot be done on the middlewares because this is a database level check that we have implemented. I cannot just write all the checks in if else, right? SQLize already does it for us. But we have to handle this check inside the services now, this particular folder, for example, this one. Now we have to actually handle it like this. So instead of handling type error and SQLize database error, for which we know that we are going to send a custom error only, instead of that, let's try to actually make a check for validation error, because for validation error we need to send meaningful response to the user that okay, this validation is not going correctly, this particular field is not validated properly, and this is something that you have to actually improve on. And the status code will become now some client related status code. I hope the overall agenda is making sense to you, that why I created a custom app error object and then I added a validation, and there can be some error which needs to send meaningful information to the end user, because this might be a client side issue as well. Now let's do one thing. Instead of sending it for type error, what I'll do is, normally every time only, instead of throwing the error, I'll just say throw new app error, cannot create a new airplane object, status code, internal server error. and here I'll say validation error. Here I will say validation error. For validation error, now technically what we can do inside the validation error object, there is a errors property which is an array. See, there is a errors property which is technically an array, and we can actually use this errors array to actually fetch our response, right? We can actually use this errors array to actually fetch our response, right? And whatever response we are going to send it from the service, controller doesn't have to put its brain. Controller will just take it and directly send it, because whatever error we will be sending from here, it will just directly send it. It doesn't have to put a lot of brain, right? All of the brainy stuff we have done in the services. So let's try to configure it. Now let's read about this validation error item that SQLize actually sends us, right? Let's read about it. So you can see validation error item instance of this class includes a validation error dot errors property, right? In this errors property, this object is present. Inside this object, you will see detailed error handling, that what actually went wrong, what is the type of the error, what property it failed on, what value you sent, and everything, right? So actually what I can do is, if we got a validation error, then I can say let explanation be an array, right? Let explanation be an array, right? And we will say object.keys on error.errors property. So you can see if I do error.errors, okay, this is an array, right? We don't need to do object.keys. We can just say error.errors dot for each. Now it's an array, right? It's an array. We'll get a error object always, and we will say explanation dot push error dot message. Okay, and let me print the explanation. Console.log explanation. Let's print explanation. Okay, let's see what comes up. Let's send it. Something went wrong and everything. And now let's see. We're not printing it. Let's see why. One second. Let's see. Got error. Got error. Okay. Validation error is getting printed. I'm not printing the array. If error dot name is validation error, let's see what is error dot name property. Maybe I'm writing this wrong spelling or something. Oh, it's SQLize validation error. It's not validation error. It is SQLize validation error. Okay. Now you might be thinking why I have put a loop here. I have put a loop here because if you will carefully see, this errors object is an array. So let's say there are multiple properties in your model. Maybe the name, the model number, capacity. There are multiple properties. And for every property, you have a validation. Then validation can at one point of time fail for more than one property, right? So explanation of all of those validation we can actually send to the end client, right? So this is going to be an array. For every failed validation, you are going to get an array like this. For example, if you go to the documentation of SQLize, you can have an is email, right? So maybe the email that you're sending is not a valid email. So SQLize is going to just directly send it to us that you didn't put a valid email. So this will be a server side check. That's why what I did was on error.errors, I did a for each, I looped on it, and inside we made an explanation array. This explanation array, we pushed the error.message. Okay. So if now I send the request, you can see inside the array, I'm getting validation max on capacity failed, right? You can even have some custom error messaging. Like, for example, you can write a whole class where if validation failed for something, you can write some other messages. But I believe this is still a fairly good message that automatically SQLize is giving us, so we can just directly send it, right? And we will always just get one array. Inside one array, we will get multiple objects with all the failed validations. We'll get multiple objects with all the failed validation. So let's do one thing. Let's try to maybe, um, let's say model number is alphanumeric. Okay. Let's try to add this validation inside airplane model number. So validate is alphanumeric true. Now model number should always be alphanumeric, right? It cannot contain anything else. Now let's say if you send something like $1 and send it. Now you can see you are getting two values. Validation is alphanumeric on model number field. Validation max on capacity field, right? So you can actually, if you want to print the whole error object, I'll print the whole error object in front of you as well. Console.log error. Okay, and send it. You can see now in this errors array, we have two validation error objects. One is alphanumeric and one is this. And technically, you can see there is a value property that what actually you sent didn't work. You can even send this that okay, this is the reason why things are not working. But for the timing, even just the message is very verbose that you can directly use, right? So just think about it. Now we have a very plain and clean array which is telling us all of the problematic stuff, right? So what I'll do is I'll send this explanation array, right? And we will say that status codes, we can say bad request. Okay. Now, if somebody sends me this, we are getting a bad request, and you can see there is a whole explanation that we are getting. Now, people will know, right? That, okay, model number is failing because they already have the API contract. So they will understand, okay, this should not happen like this. Or capacity is failing, this should not happen like this. A lot of time people feel that these kind of checks should only be present on the front end, not on the back end. That's a very wrong approach. Every validation check should be on the front end also and should be on the back end also, because there won't be always a case that you are only going to interact with your backend from the one of the front ends only. Maybe there is another service that is, or let's say some another backend app that is going to make an API call to my backend app. Then maybe if in this case the one who is actually making the call is the client, maybe they don't have the validation put in place, then it will be a problem. Apart from that, let's say you have a mobile front end, web front end, and a desktop front end. Let's say on the web front end and the desktop front end, you have validation in place. But let's say you forgot it on the mobile end, then also it can create problems. So always the validation, at least in my opinion, and whatever I've seen till now, should be in place at both of the cases. There should not be a case that front end is not handling it, just back end is handling it, or front end is handling it, back end is altogether not even handling it. Until or unless you are very sure that there is no other way that this backend service can be called by something else apart from my one particular front end, I believe apart from that particular case, you should always have validation checks on the backend. If you're very sure that only one single front end or two, three single front ends are only going to interact and they have the checks in place always, then maybe you can skip it. It can be then opinionated. Let's say currently whatever is the messaging given to us by corresponding SQLize ORM, we are just sending that. Let's say you want to have custom messaging. For custom messaging, you need to have custom cases, right? So you can very easily get custom cases. For example, you just don't want to say validation max on capacity field. You want to say something like the maximum value of capacity can be this, and you have violated that, something like that. So you can actually make separate classes altogether where you can use this validator key as the parameter to actually check what kind of validation failed on which particular property of the model, and then you can prepare custom messaging corresponding to that, right? But for at least a personal project, a small project, even the errors that is coming to us from SQLize is pretty verbose, and we can actually live with that. Okay, so this is how things will work for us. You can see most of the logic is now inside service. We can actually remove all the console.logs. and things will start working well for us, right? And you can see cannot create a new airplane object, looks good. And let's see, if you go to your controllers, you can see inside the controller we just catch the error, whatever is the error property, we add it to the error response error property and just send that error object. That's it. Let's do the similar thing in middlewares as well, right? So here the error response dot error should not be just this plain JavaScript object. Let's do something like this, that new app error, right? And inside the explanation we'll pass an array. This array is going to take this messaging, and we will say status code bat request. That's it. And we can actually set this here. Okay, this looks cool to me. Let's save it. Now if let's say you will not send model number, see again now custom messaging and consistent messaging. Client will always expect explanation to be an array. You can see we are sending an array. We have a 400 bad request status also set, and everything is now more consistent and clean. Now whatever will fail, based on that you will get corresponding messaging altogether. If everything is good, if everything is good, then maybe you will just directly save it. Okay, you can see alphanumeric failed because there is a space here, and let's say there is a space here as well, right? You can see successfully completed the request. So on and on, whatever level of detailing you actually want with your project, you can actually do. The cleaner you will write, later when the project will become too big, it will be cleaner to maintain, easy to expand, easy to extend. Everything will be very easy if from very initial stage only you will maintain very hygienic and clean code. To be very honest, there is one very bad and smelly thing that I'm doing with the code that is okay for a personal project. That is these raw strings. Most of the time, you will see that raw strings are not that good, right? Because maybe the same string might be getting used somewhere else, or just writing raw string doesn't make sense. So always we can have a separate strings or messaging kind of a JSON object or something, or JavaScript object or something, where there should be key value pairs. And instead of writing raw string, we should actually import the corresponding messaging from there. Generally, you will see in production level code, people always follow one thing. They never write raw strings. I'm specifically telling you, we are not going to follow it in this project because it's going to be on very small scale, and otherwise it will take us a lot of time to always prepare a variable here and then use it here. For at least our use case, things look still pretty fine to me, right? But generally in production level code, you will see that people not even put raw strings anywhere lying here and there in their project. One of the reasons is something called as translation or internationalization, right? Because just think about it. If let's say this messaging that we actually sent from the backend to the client, let's say the client is directly going to use it, and let's say it's a mobile app. Now inside a mobile app, there can be multiple languages, right? So if there are multiple languages, how this thing is going to be handled, right? So generally what we will see that in the backend services, there is a separate translation service that people add, right? And again, I'm talking about very high scaled projects, which is used by millions of people. For example, some projects of let's say LinkedIn, or let's say at the scale of Amazon or Google. So in that case, these strings are raw strings will not get converted or translated. That's why we generally prepare a separate strings folder. And whenever those strings are getting used anywhere, that translation service pulls in and converts or translates it corresponding to that, and then send it to the front end, right? Or maybe there can be a translation mechanism on the front end. Some
mechanism can be there. This is one of the use case of keeping things, keeping strings, raw strings separate. Another is definitely there can be a lot of redundancy. Same string you are sending again and again, again and again. Something went wrong, something went wrong. Everywhere you're writing something went wrong, and always you're writing a raw string. For example, some in one of the something went wrong, you did a wrong spelling. You made a spelling mistake. That will be inconsistent, right? So maintain more consistency. Technically, we should also store all of the raw strings at one place. But for the timing, at least at this scale, we don't need that. And you will see a lot of startups also don't follow that. So now let's talk about our airline booking service. So if you have seen anything like Google Flights, you're going to build kind of like this. Of course, not on the interface level. We're not going to prepare this beautiful UI. But yes, we are going to try to make sure that people get an end-to-end flight booking experience, right? For example, people should be able to actually search for flights. For example, they can actually give some custom date, right? Then they can actually give number of persons. They can actually give class, economy, premium economy, business, first, whatever it is. They can give the starting destination, they can give the ending destination, and then they can actually search for it. So we need to actually maintain or prepare the whole project so that we should have API calls where people can actually search for corresponding flights. Then you can have multiple filters, for example, the number of stops, the different airlines, baggage, price range, right? Time range, emission. Of course, not everything you can do, because after one point you will realize that it's becoming redundant. You can actually order things. For example, you can sort by, let's say, price, or let's say you can sort by duration. These kind of things actually you can do. You can sort your data based on multiple properties, right? And then we can actually try to give more end-to-end, I would say, experience to the users. For example, let's say they selected a flight. They actually selected a flight, right? uh, Continue. Okay, they selected a flight. Okay, so once they have selected the flight, then what we can do is we can actually help them to book the flight. While booking the flight, then there will be a lot of constraints. For example, if let's say there is only one seat left in the flight and you want to book 5 seats in that flight, it should not happen, right? Price calculation, how price calculation is going to be done. We're not going to prepare a whole payment service. We'll try to mimic the payment somehow, right? Apart from that, once you have booked the flight, then you should get a notification that you have actually booked the flight. 48 hours before your flight, you should actually get a notification that you need to actually complete your online boarding, right? Then once somebody completes the boarding, let's say the online boarding stuff, then we can actually mail them kind of like a the whole, what do you call it, mm, along with the ticket. Maybe you can send some details, like you can send a QR for getting your access on the airport, right? You can actually mail them a whole PDF around the date and everything, right? All of these things, you can actually mail them once they have completed their online boarding, right? You can set up some reminders for them, right? You should have mechanism for cancellation of the bookings, right? And multiple stuff, right? If let's say a gate change or time change notification, sometimes what happens is, due to some issues, airlines have to actually move their timings. For example, if you have a 5 p.m. flight, they might move it to 5:30. So any kind of a change should be notified to a user, right? These kind of stuff. So an end-to-end booking service we will try to prepare, right? And there will be a lot of things that we have to actually learn in this. You might feel like that, okay, we have to just prepare flights and then just filter out things out of them. It's not like that. There will be small engineering issues that will come in this whole flow, right? We will talk about that how you can actually handle it. I don't want to disclose it now, but there will be small important engineering aspects and concepts that you're going to learn while preparing all of this, because booking mechanism is something that is pretty important to understand, right? We can also try to prepare, like, this whole booking service can actually help you to understand something like a movie booking application as well. Let's say similar thing exists in movie booking applications as well. You have movies, they are associated with theaters and everything. Then you have to prepare a booking, you will select some seats, then you have to, based on the number of seats, you have to actually make a booking, all of that, right? So a booking service is actually part of most of the applications. A lot of applications that you will see, some kind of booking mechanism actually exists there. And there are some challenges that actually comes with these kind of infrastructures that we will understand once we start building the application, right? The whole application that we are going to build is going to be a microservice based architecture. I'll do the high level designing of the application, where I'll talk about what services we are going to keep. But definitely we will keep at least 2 to 3 services. Every service will be having their own use case. Let me give you one possible use case. You just think yourself, when you actually book a flight, you book one flight. But for booking one flight, you can see people actually spend an hour or 1.5 hours on the booking application. They will try to see what is the best price for two flights. How much is the price? Is there any discount? Is there any alternate flight? Is there any alternate route? They spend a lot of time in actually querying all the flights, but end up booking one flight only. So the overall flight booking mechanism looks more like a read heavy thing. A lot of reads are going to come up when compared to a write, right? So if you will just make one monolith where your booking logic is also present there and your flight searching logic is also present there, then there can be cases where you have a lot of traffic. For example, during uh, year end, a lot of people actually plan a bunch of travel and everything. In that case, you have to scale that whole monolith, but it doesn't matter, right? Because your searches are going to increase at an exponential scale, but your actual booking might increase at a linear scale. So you don't need to scale up both of the things at the same pace. So maybe you can have a separate flight service where you can search for the flight, you can query for the flight and everything. And once you are good to go, then the booking part can be handled by a separate service. Then the reminder mechanisms can be handled by a separate service, right? All of these things, authentication, where should the authentication part should go? All of these things are going to be very important when we'll try to understand the high level design, right? We'll also talk about design docs, like how do you work with design docs. Generally, when you build one feature, then you actually prepare a design doc for that. You don't prepare design doc for the whole project. You prepare design doc per feature, because every features, all the possible approaches, what approach you took, what approach you not took, all of these things are actually present in the design doc. So it's prepared at feature level. For every feature, we are not going to print a design doc, but I'll prepare a design doc for one of the most important features, that is going to be booking. We'll spend some good brainstorming time and see some important aspects of how things work in booking. I'll prepare a design doc for that, and I'll show you that how you can prepare good design docs, right? And whatever things we are going to build, first of all, in the next part, we are going to actually build a high level design of how exactly the services will look like. And then we will one by one work on each service, preparing the services on our scale. At least at the coding implementation, it's not going to be very complex. I'll also make sure that I don't implement everything. I'll give you take home tasks that you can yourself implement based on what imagination you get based on that. For example, if there are filters, I will not implement like 10 filters. Maybe I can implement 2, 3 filters, and then 3, 4 more filters you can add yourself. So there will be takeaway tasks with every single milestone that we are going to get in the project. And this whole project is going to give you more wholesome experience, because after this project, we have a monolith project. That monolith project will look like just a very small part of it, because everything will be done in the same project only. So that will look like a cakewalk if you understand this particular project well. So we'll be doing the high level design in the next part for it. Now, in this whole project repository, we have actually touched base upon most of the things. The only thing that is left is this seeders folder. Looks pretty empty, right? Now, what is the use case of a seeder? As I said, when you are actually testing stuff, then these seeder files can be very important, where you just can start your database with 5, 10 basic seeded values. Or let's say if there is a table that will never get new values, it is only going to get a particular set of values, you can actually prepare seeders for that. So let me show you an example. Okay, so what you can do is you can write something like npx equalize seed generate, okay, minus minus name. You can give a name to the seed, and let's say I'll say it as add uh, airplanes. Add airplanes. Okay. The moment you run it, you can see it will create a new seed file, add airplane.js. Okay. You can see this new seed file. Now you can see in this seed file, it will give you the whole structure altogether. And it's going to be very easy to use, extremely simple to use. Right? How? In the async up function, whatever entries we have to make, we can make those entries with a bulk insert. So we can run a command called as npx equalize db seed all, and it will start seeding all of our seed files, right? And if we will do undo of the seed, then it is going to delete a bunch of things. Like all of the seed files will be deleted in case you did a wrong seeding. Okay. So let me show you. Let me show you. So I'll copy this code. Query interface dot bulk insert. They are going to make the name of the class here airplane. Okay. And it takes an array. See, it takes an array. And then inside the array, it will take separate objects. So let's say model number, Airbus 380, capacity 900. Okay. Then add one more object, for example, model number, Boeing 777, Boeing 777. And let's say I'm just running a random capacity 450. Okay. So let's say these are the two objects that I want to insert in my database. Okay. Currently, let's see what do we have already in the database. So let's start from airplanes. Sorry, no database selected by mistake. Sorry, use flights. Okay, so we already have Airbus A380. Let's get some other model. Airbus models. A340 is also there. Let's add a seat for A340. Okay, cool. Now, how can you add a seat? You can just do npx sequelize db colon seed colon all. So whatever are the seed files, all of the seed files will be applied on the corresponding database. If you press enter, okay, it says flies.airplane doesn't exist. I guess you need to do airplanes. Let's try again. And now you can see it is throwing an error at created at also. Now why it is throwing error at created at? Because if you carefully see, we have a created at and updated at property as well. So you need to actually mention those things as well here. So let's quickly add it. It will be simple. Created at new date, updated at new date. Okay. And I'll copy paste the same here. Comma. Let's try again. So whatever is the error, their error messaging are pretty useful for SQLize. And you can see it actually seeded something. Let's see. If you do select star from airplanes, you can see we have more entries. And now just think about it. If let's say you have a roles table, that what are the roles of a user, and you are making an e-commerce application. The roles of the user can be what? Seller, admin, maybe let's say some sub admins, and let's say normal user. Okay, buyer or normal user. So you can actually have four roles. You are very rarely going to change these roles. So you're not going to prepare a whole set of APIs for it, right? You're going to prepare a whole set of APIs for it. In that case, you can just seed your table. Apart from that, if let's say you are locally building something, now sending an API call again and again, again and again, every time you do something, let's say if somebody else also has to work on the same project, they have to create the whole database on their own by sending an API request again and again. Instead, they'll just run the seed files and all of the data will be directly populated, right? So if you go to SQLize CLI, You can actually see they talk about the seed files here. See, sequelize, db seed all, seed generate and everything, right? You can actually also Google how to seed a particular seed file, sequelize. Then your unique number is going to also help. Let's see. So how to seed only one file? See, very easy. Sequelize db seed minus minus seed and your file name. Whatever is your seed file name, just write that seed file name, then only that particular seed file will be applied. If you will do db seed all, then all the seed files will be applied. Okay. So now if you do, let's say db seed all undo, there is an undo command as well. So you can say undo all. In that case, let's see what happens. It says it's going to revert. It says it's going to revert, but it didn't revert anything. Why? Because in your custom implementation, you have not implemented anything for down. What should happen in case of down, right? In that case, let's add it. So whenever you do undo, this down function is applied. Whenever you do db seed, this up function is applied. I'll say await query interface dot bulk delete airplanes. You'll put plural here, right? Then there are two more parameters that you can put, right? There are two more parameters that you can put. Technically, this object parameter is the only thing that we have to actually go for. Now, if you will see, leave this plain, then all of the entries from the airplanes table will be gone. I don't want to leave it as it is. So I'll add an operator. I'll directly add an operator here, right? So let's do something like this. Const from require sequelize, and there is a operator op. Okay, we can say op.or, right? We'll put an or operator, and then we'll put an array. Inside the array, we will say model number is this, or model number is this. So wherever the entries are there, one second. Wherever there is an entry with model number Boeing 777 or Airbus 340, only those entries will be deleted, nothing more, nothing less. If you will keep this object plain empty, then all the entries will be deleted. Now you might be thinking where this op.or is coming from. If you remember the sequelize part, then in sequelize I showed you that there are custom operators that sequelize provides using the op object, op.or, op.and, op.equals, all of this, op.between. So this is technically coming from that ORM implementation. And now if I again do db seed undo all, it's going to apply the db seed, and let's see what happens. You can see all the entries of Boeing 340, sorry, Airbus 340 and Boeing 777 are gone. If I applied the seed again, let's try to apply the seed again. The entries are back. Remove again. Entries are gone, right? So this can be a very simple way to actually prepare a sample database, seed it, and start working on that project. Generally, it will be very relevant for very big orgs where you have very new people actually coming up and you have some old project. So in order to make their setup part easy, or if you have a table which is never going to get any other values, these seeding mechanism are going to be really very useful. Guys, let me just quickly refresh your memory on operators, because we have actually used that here. So in sequelize, if you have to write some custom operations, for example, some greater than, what is greater than 6, greater than equal to 6, less than 6, less than equal to 6, or let's say on the where query, you have to use the and operator. So you can actually use the op object from sequelize module. If let's say you have to do op.and, that means you have to do a and query here. You pass an array. In the array, you pass all the objects which have a key value pair. Key represents the column, value represents the value of that column. So wherever these conditions are going to be satisfied, for example, a equals to 5 and b is equals to 6, the query will be applied. In the op.or, a is equals to 5 or b is equals to 6, right? And there can be some custom implementations or custom attributes. For example, there is a, let's say, price attribute. Price should also always be greater than or equal to 0. So you can say price colon, and you can have an object. Inside that object, you can say op dot greater than or equal to 0. So price will be always greater than or equal to 0, something like this. So these operators are very powerful and will be used very regularly in a lot of SQLized based implementations. That's why I've technically used them here as well, right? I'll just clean it up like this, and we'll be having an array like this. Okay, looks cool. Looks cool and better to me. Okay, so that's how you can actually prepare seed files, right? In seed files, async up function, you can actually insert a bunch of data. In down function, you can delete a bunch of data, and technically anything is not restricted. You can see it is calling query interface dot bulk delete. Maybe you can try what will happen if you will start calling bulk insert here. Is that going to do anything wrong to you or something like that? So you can actually explore that, but I believe few things are pretty obvious, that this is just internally calling a bunch of functions only. It's just that the whole file setup and everything and these command setup is actually given to us by SQLite, so we don't have to make a lot of effort here.
So now we know that what project we are going to build, but we'll try to do some system design analysis on the project, right? The system design analysis we will do considering that, let's say if you went for an internship and then you have to do this kind of analysis, then what could be the ideal way? It's a very small project, so of course there won't be a lot of components that we are going to build, but we are going to opt for the microservice based architecture. We'll see that what different services we need to make, what are the different layers that we need to have, all of these things. So we will try to actually prepare. We'll see that what are some of the non-functional requirements and the functional requirements that you can actually build for the project, right? There will be a lot of features that we will definitely build ourselves in class. A lot of features should be a takeaway assignment for you, right? So we are going to do that, right? And you will see that this kind of an analysis only you have to actually do when you move forward for a system design interview, right? In a system design interview also, this is a complete project that we are going to actually design, but generally in system design interviews you might be asked a question to prepare a particular component of the whole application, right? For example, if you like if you take my own experience, then in Bloomberg I was actually asked to prepare a notification service that can send notifications to users on uptick or of a particular threshold after a particular threshold of a stock. So you can actually do that in some kind of applications. So I was asked to prepare a system design corresponding to that. I was asked system design of top K trending tweets as well as designing a basic Facebook news feed in LinkedIn. So there were a few more system design rounds that I gave where I was asked to design a flowchart kind of an application for front end and everything. So multiple different interviews I gave. Generally in interviews, the approach remains same, that you have to actually move forward with some assumptions, some estimations, and try to design some basic set of components, right? So we'll take a look at that how we can actually move forward based on our flight booking system or airline booking system. We'll try to talk about that, right? We'll be preparing some diagrams here because in an interview also you will be asked to prepare diagrams on these kind of online applications, right? And we'll try to have some functional non-functional kind of requirements as well. Now let's try to actually have some requirement analysis, that what we expect to have in our project, right? So let's say that we'll write some non-functional requirements, because some functional requirements we have already seen when I actually showed you that Google Flights interface, that what you can actually do. So some of the functional requirements we already know, right? We'll try to write some of the non-functional requirements now, right? So let's have a bullet point kind of a structure, right? So what we can expect is that we can expect more flight searches than bookings, right? If you compare with bookings, you can expect that there will be more flight searches rather than more bookings, right? Apart from that, the system needs to be reliable in terms of booking, right? For example, in booking, things should not happen like you are deducting someone's money 2-3 times, or the money has been deducted but the booking has not been done. These kind of things should not actually occur, right? And then uh, technically we should be able to handle, let's say, expect that like these are the assumptions that we are making. Generally in an interview you will be just asked to uh, design a airline ticket booking system. Now these requirements that I'm writing, you have to discuss with the interviewer that is this a good requirement that we are taking, is this required, is this not required, all of these things, right? So depending on your conversation that you will be having with your interviewer, they will tell you that what are the requirements, what are not the requirements. And these requirements you have to think yourself. It's not like every time they will give it to you. You can discuss it with them that whether this particular component is required or not, this particular feature is requirement or not, whether this non-functional requirement is there or not. Now there are two type of requirement: functional and non-functional. Functional requirement actually refers to the major features of the application. Non-functional requirement actually tells about the overall infrastructure, what is the expectation out of the infrastructure that we are going to build. Okay, so let's say we can expect that we will be having 1 lakh total users, right? And just think about it. If let's say we have 1 lakh users signed up on our application, max in the worst case, what can happen? Like uh, everyone can do one booking in 1 quarter. Like if you will see, people not even book 2 flights in a month. So they might do one booking in 1 quarter. And let's say in one booking, they might be booking for their whole family and everything, right? So there can be a case like that. So I'm assuming that I'm assuming that 1 lakh bookings, 1 lakh bookings might come up in a quarter. And these are for registered users, those users who have actually signed up for to our application. Generally, you will see people don't even sign up to the application until unless they have to make their first booking. For example, you can go and roam around in Google Flights. You don't need to do any sign up to make my trip or go IBB or anything, right? You actually make that sign up once you actually start booking things so that you can get notifications and everything, right? So if you're getting approximately 1 lakh bookings, and we assume that in a quarter there are 90 days, so you can make an approximation of approximately 100 days. So you can say that in one day, you might be getting 100 bookings. Of course, I believe applications like Indigo might be booking at a much higher scale, but for an initial starter, this can be a relatively good requirement analysis. And again, how many users are making the booking, how many users total you have to expect, you have to discuss this with the interviewer. No design is perfect, no assumption is perfect. It's all about what they want to actually ask on. So that's on that, in that particular direction they're going to move the interview to. Okay, then system should be able to make sure that we don't change the prices when the booking payment is going on, right? Now this can be a good assumption to make, that it should not happen that your payment is actually going on and the price got changed, right? Let's say you put your card details and then the price got changed. I don't think this is a very good design to go for. Always when you are actually exploring, you are writing your email and you are yet to start the payment, at that point of time the price can change. But let's say the price of a flight was 2000 rupees. You clicked on start payment and now you are writing your UPI ID. You wrote your UPI ID, that page is not going to refresh. When you click on start payment, it's going to make a request to the UPI ID. it should not happen that on the UPI ID you are making a request of 2500 rupees, because the price changed in like 2 minutes. The price can change before the payment actually starts. Once the payment has started, once the payment process has started, we should not update the prices, right? So this kind of assumption we can technically make, that okay, this can be a good assumption to go for, right? We don't change the prices when the booking of the payment is going on, right? Then there will be some very basic checks, right? For example, the seat bookings and everything, those are going to come in functional requirements, right? Then let's say system should be able to auto scale itself, because for at least 3x more traffic, right? At any point of time, there can be a case that you might get 3 to 5 times of your regular traffic. For example, let's say during year ends, you can get a lot of requests, at least for search, if not for booking. So your system should be able to auto scale things around that, right? Then generally in an interview, you have to also do something called as a capacity estimation. Capacity estimation means that how much space you will need in order to store all of the data, right? So generally you do a capacity estimation of approximately 5 years, that if in 1 quarter you are making 1 lakh bookings, in 1 year you'll make 4 lakh bookings, in 5 years you'll make 20 lakh bookings, right? So you have to store the details of these bookings, then you have to store the details of the users, all in all. So that kind of a capacity estimation also you have to do a lot of times, right? But generally in capacity estimation, a lot of things are very vague. Even if you do a bit of capacity estimation here and there, it's not a deal breaker. You can assume one particular type of data is going to take, let's say, 10 bytes. So for 20 lakh records, how much bytes is going to take, then convert it to gigabytes or terabytes, and then tell that okay, this much amount of space will be required to actually store it. Until unless it's a very bizarre design that you are creating on the database end, by that time, till that time, nothing is going to hamper you a lot. Okay, so I'm not doing capacity estimation here. These non-functional requirements should be suitable for us, right? In these non-functional requirements, I've written basic system ideas, that what the system should be able to actually do. What are some of the caveats that we need to have, right? And so on and so forth, right? So functional requirements, we have already discussed that user should be able to search for a flight, search with based on filters. User should be able to book a flight. After booking the flight, they should get the boarding pass, right? And but technically they should get immediately a notification and the ticket, and later, let's say if they are completed their online boarding, then they should get a boarding pass with a QR. Whatever are those requirements we have already discussed, these are some of the system requirements, right? A lot of time you might feel that for how long the data of a user should be there. I believe travel history is an important part of, for many reasons. For example, even for government use cases, you might need someone's travel history of, let's say, 10 years back, where he or she was 10 years back. So I believe we should be able to persist data for a very long period of time, right? And a lot of time people also see that okay, I went to, like, if you are going for international travel, you don't do international travel like every month, right? So in, let's say, 2 3 years, people do an international travel. So they have to, let's say if they want to go there again, for example, if it's a place like USA, so in US you won't be able to cover the whole US in one travel, right? Generally. So maybe you went to USA 3 years back as well, so you want to see that okay, what was my itinerary in that case, where did I stay, what was the price of the flights in that case, in that time. So all of these things you might have to yourself see. So at least we should be able to persist the data for good amount of time, maybe more than a decade or something. But I guess this can be a assumption that is depending on company to company and where the company is actually working, because these kind of decisions are also compliance dependent, that what compliance government is putting, that how much data you have to store, what they can actually ask for, and so on and so forth. So these are again dependent on business to business. Whatever data storage we are going to use, we will definitely try to persist as much data as possible. Now if we talk about the architecture, that how our application will actually is going to work, then there can be multiple front ends that might actually interact with our application, right? For example, there can be a mobile front end, right? There can be a mobile app that we have prepared, right? And then there can be a web front end as well, right? So we're not going to talk about which technology we should use for mobile or web front end, but this is going to be our client side, right? That we can have different type of we should have different type of client support. This is our client side, right? It can be a mobile app also, it can be a web front end also. In very complex use cases, you might provide your services to some other companies. For example, if you look for Flipkart flights, like Flipkart doesn't maintain a lot of things themselves, they actually use another service. So if you start booking on Flipkart flights, let's say book now, let's say I book for from Bengaluru to Hyderabad, right? To adult search. Now this whole interface that they are having, this is not like everything is not actually maintained by Flipkart, right? I guess previously they used to show as well which APIs and everything they are using. For example, if we try to book this Aksa Air, let's see if you are able to see. You can see a bunch of these things going on here and there, right? They're asking for review itinerary, and okay, now they are not showing it, I guess. Here, let's see. Flipkart flights is powered by, I guess they use Make My Trip, right? Offers. Now you can book flight tickets on Flipkart app, which is powered by Make My Trip. So Make My Trip provides services to Flipkart. That's where Flipkart actually is able to show all of these things, because maybe if you book it from Flipkart, Flipkart might provide you some additional discounts as well, right? All of these things. And you can see a very basic API they are actually maintaining. If I try to search for it, let's see this URL, what this URL is actually telling us. Let me open Sublime. Very basic URL they have. You can see flipkart.com/travel/flights, and you are searching for a flight. Now the trip is from BLR to Hyderabad. So every city they have most probably encoded with a code, right? This is the date. I want to go for 11th of May 2023, right? How many travelers? Two travelers. What are the other two components? 0, 0. If you actually see, if you go back, number of children 0, number of infants 0, right? So 200 is actually referring to this. So see how simple API they have actually prepared. We are able to just understand it directly. Class is equals to E means economic class. Trip type is equals to one way, means there is not a two-way flight. Is international is equals to false. Of course, if it's not international, so a lot of compliances are not going to come up, right? What is the source of the search? Like, this is not important for us. This is generally for their own tracking purpose, that the user that is landing on where they actually started their journey from. So we started our journey from this search page only. So that's where we came up and landed, right? So all of this %20 that you see, these are URL encoded characters. I've already talked about it, that what is a URL encoded character, and that we also mentioned in our Express app as well, right? Some special characters are URL encoded like this. Okay. Now you can see now from here, let's say if I change the date, for example, if I click on 12th of May, you can see the date changes here. See the date changes here. If I change to 13th of May, you can see now the date changes here. If I change from Hyderabad to, let's say, Kuala Lumpur, so they have a code for that, KUL, most probably it will become BLR to KUL. The moment I click on it and select the date, done, search again, see it became BLR to KUL, and it is also international. So they are able to make a filter of international flights as well. So you can see very simple search queries they are actually able to put, right? Let's go back. Now, let's say if you try to book Aksa Air, okay. Now you can see, you don't see much of a detail here. The only thing that you see is the review page. That is, you are able to review your itinerary. And this is the itinerary ID. So most probably they actually maintain something called as an itinerary there. So once you start actually booking, currently also the price can still change. This price can still change. Okay. Now let's say if I click on continue, all of this is going to actually through a post request. So the details of the itinerary that came up here is actually coming through a post request. That's why you don't see that in the URL, right? Then let's say you can add some details. For example, Mr. Sanket Singh. Okay. Did I book for 2 travelers? Let's change the itinerary to 1 traveler. Let's change the itinerary. Let's go back. 1 traveler only. Search again. It's a pretty cheap flight, I can see. Okay, continue. Okay, contact information. It's gonna ask for contact information. I'll say, oh, my number is getting shown here. Da, da, da. I should not have done this, but okay. Enter a valid phone number. Okay, let me do this. Okay, I've entered a dummy number. I'm not sure if whose number it is, but okay. I don't want to add any GST details. If I click on continue, now you can see it's creating the travel itinerary based on my name and everything. Now you can see it has created a new token. And now here, the price should not change. This is going to be a very bad design if they do it, but technically in our app, we are not going to do it. Once the price is logged, this price is logged. If I make the payment in the next whatever minutes I have, 19 minutes, this price is going to be something that I'm going to be charged for. It's not like I put my credit card details, I clicked on continue, and they charge me for something else. If I search for the same thing again, maybe the prices on the search history will now change. But here up till for the next 20 minutes, they have technically logged me with a token. So we also need to maintain a similar kind of, I would say, experience. Of course, not on the front end, but on the back end, we are going to maintain. There are a lot of caveats that goes on behind the scenes in this case. But for the timing, we actually are able to understand this, right? So there can be different type of front end, either a mobile client or a web front end, right? Then these mobile clients and web front end. Now, what will happen is a lot of people think that there will be one server and these clients are going to just directly interact with the server. This is not going to happen. It's not going to interact with the server, right? Because we are going to maintain a microservice architecture. There won't be one server, first of all. Okay. There will be multiple different services that are actually going into the picture. So what the client is actually going to do, client will not interact with the servers directly. All client has to do is client just need to make a request that we call as the load balancer, right? Client will just make the request to the load balancer, nothing more, nothing less. This load balancer is actually going to be responsible to actually redirect our request to the internal server based on which server is healthy, which request is coming up, and so on and so forth, right? Now, in fact, this load balancer also doesn't directly just communicates to the backend services, right? There is going to be a layer in between the load balancer and the services, but I will first of all like to talk about the services, okay? One service that I can directly see is going to be a search microservice, because we should be able to do all of the searches, right? That we are able to do on our application. Different filters are going to come up. People will be able to search for the flights. They won't be booking it because a lot of time people just search it and go away. So our search service is going to be different because we can expect good amount of load on our search service. So if required, we can just scale up our search service, if not the whole application. So there will be one search service that is going to handle all of the searches. There is going to be another dedicated booking service. There is going to be another dedicated booking service. What booking service will do is, once the search service gives the request to the user, now if the user wants to start the booking, those booking details are going to be transferred to the booking service, and booking is going to be maintained in the booking service, right? This is going to be one thing, right? Apart from that, there will be another reminder service. And of course, we are making a microservice architecture, right? So every service is going to be a different server altogether, right? We are going to have a different Express application for our search service, different Express application for booking service, different Express application for reminder service. They are going to be absolutely different Express apps. They will be communicating within each other, right? So now let's see. Apart from this, apart from the reminder service, what we will need is that is going to sit between all these three. Okay, we need a service that is going to sit between all these three. Now just think about it. If the front end makes a request to for searching something, okay, so are we going to give the address, IP address of our search service directly to the front end, and IP address of the booking service directly to the front end? No, right? The front end should just give us a request that I want to search something, and which service is internally handling the search, that should be just known to us. For these kind of reasons, we add a layer in between called as API gateway. What is an API gateway? So what happens is the load balancer actually forwards the request to API gateway. Inside the API gateway, we have something called as our reverse proxies as well. What is a reverse proxy? Think about it. So our mobile frontend is just going to tell us that, or web frontend, whatever frontend, is just going to tell us that I want to search for something. After some time, it might say, I want to book for something. I want to cancel my booking. It is just going to tell us what request it has to actually make. Now, load balancer's only task is to balance out the load between the whole architecture, right? Now, what will happen is this API gateway is actually going to be responsible for taking the request from the front end through the load balancer. And this API gateway will resolve, okay, this request is going to belong to the search service. So let's forward this request to the search service. Okay, let's follow this request to the search service. For example, what's the proxy? You might have seen people putting proxy in colleges, right? Proxy is what? Someone else is pretending to be like you, right? When you say, no, that bro, please put my proxy for this particular class. So what are you requesting to your friend? You are requesting your friend that please try to be like me. Of course, you're someone else, right? But just try to be like me. Just try to show that this you are roll number XYZ, right? Same thing API gateway is going to do. API gateway is going to just collect all of the requests from the front ends through the load balancer. The front end won't realize that actually these requests are not going directly to the search service. This is going to go through a API gateway. A lot of time you also call it as the middle end. You also call it as the middle end, right? You also call it as the middle end, right? This API gateway, a lot of time people will call it as a front end server as well. That the front end requests are going to be accumulated here. And then this API gateway is internally going to forward the request to the corresponding services. Now, there are a lot of use cases of API gateway. First thing, you don't have to hard code the addresses or the overall socket address of every service on the front end. So front end just knows about one server, and that particular server internally routes all the requests. First thing. Second thing, API gateway can also help you to act as authentication service also. In the API gateway, you can add your authentication logic, and if a request is expected to be authenticated first, you can authenticate it directly in the API gateway and then only move forward to any of these services. Apart from that, there can be a case that mobile front end sends you a request that, okay, I want to do this booking, or I want to create this itinerary, or I want to, let's say, lock this itinerary. So itinerary details, this API gateway might have to fetch from the search service, right? Or let me give you a better example. For example, let's say you want to cancel a booking, or you want to modify a booking, something like that. For that, you first of all need to go to the booking service. You first of all need to go to the booking service and fetch the details of the user booking. Once the booking service gives you the detail of the user booking, then you might need to go to the search service to see that, okay, is this flight still modifiable? For example, are there seats left? For that, search service is responsible. So you will go and collect the request from the booking service and then go and redirect this request to the search service, right? And so on. So if you have to do multiple service level aggregations, then you can do that to API gateway. But there is again a problem. We don't want our API gateway to act like a lot of things. We are doing authentication on the API gateway. API gateway is going to act as a reverse proxy, right? API gateway can also contain your what do I call it? Uh, so API gateway can also include the logic of your rate limiter. For example, your front end is actually sending a request by some script or some bot. So you don't want your services to actually get impacted with that. So what you will do, you can actually put your rate limiter logic also in your API gateway. So your API gateway is doing a lot of things. Your API gateway is doing a lot of things, right? That's why technically you can do one simple thing. You can do one simple thing. If you're not able to understand what is a reverse proxy, right? Let's see this diagram. Let's see this diagram. Okay. So, one second. Okay. Now here you can see there is something called as a forward proxy and something called as a reverse proxy, right? In forward proxy, what will happen if there is a user will directly send the request to web server A, web server B. If there is a reverse proxy, then this reverse proxy is actually going to set up in between like a layer, and this reverse proxy, it actually is going to take up the request of user A to send the server request to web server A and web server B. User A will just tell, okay, this is the request that I want to have. This reverse proxy internally has the logic, okay, this request should be redirected to web server A, this request should be redirected to web server B. So you are not going to just directly communicate via the internet to the web servers. You will just communicate to this reverse proxy. Internally, the reverse proxy is actually going to do stuff for you. For example, something like this. You as a user will just send the request to the reverse proxy. Reverse proxy will act like search service also. It will act like reminder service also. It will act like booking service also, but it is not actually neither search service nor booking service nor I would say reminder service. Instead, what it will do is it will collect the request and redirect it to all of them, but the end user will feel like you are actually communicating directly to the services. This is what reverse proxy actually do, right? Think about it like your normal proxies that you actually get in your, I would say, colleges. Somebody else tried to act like you. So this reverse proxy is trying to act like my web servers. It's not the actual web server. It doesn't have the actual logic. What it will do, it will start acting like my web server. It will collect the request, and in the request, it will identify, okay, this request needs to go here. It will send the request there. This request needs to go here. This will send that request there, and so on and so forth. So what is a forward proxy? A forward proxy, also known as a regular proxy or a proxy server, is used to receive and forward client connection request to a destination web server through the server. The two common types of proxy servers are data centers and residential proxies. A forward proxy server is placed in front of clients directly, right? What is a reverse proxy? A reverse proxy is a server that is positioned in front of web server. So you can see forward proxy is positioned in front of the client. Reverse proxy is positioned in front of the servers to ensure that the security of the incoming of the from the external sources. That is, whatever request is actually coming, any kind of rate limiting, request filtration, anything you have to do with the traffic, you can actually do it on the reverse proxy. It accepts and receives incoming traffic on behalf of clients. It's going to receive all the traffic on behalf of client and then forward that traffic to the corresponding web servers, right? For reverse proxy, a client sends the connection request. Instead of connecting the client directly to the web server, the internet forwards the client connection request to a reverse proxy. The reverse proxy communicates with the web server. The web server provides the requested information to the reverse proxy. The response from the origin server is received on the reverse proxy and sent back to the client. So in simple terms, if you don't want to go a lot in detail, you can say that this API gateway will also contain the logic of our reverse proxy. What reverse proxy is going to do, I don't want my front end to directly communicate to the search service or directly communicate to the booking service. Our front ends are going to just send the request to our proxy. Proxy will decide, okay, this request needs to be sent to web server A, this needs to be sent to this service B, so on and so forth. When these services are going to compute the request, they are going to send it back to the gateway, and then gateway will send it back to the corresponding front end, right? Okay. Now that's why I said that our gateway is already doing a lot of tasks. You can do rate limitation here. You can do authentication here, right? You can set up your reverse proxy here, everything you can do. Apart from that, currently my API gateway is also doing data aggregation. What is data aggregation? For example, as I said, if you want to actually modify a booking, you will first of all go to the booking service, get the details of the booking, that this user made booking to this particular flight for this particular day and this many seats. Now they want to modify the booking. If you want to modify the booking, then you need to actually go to the search service. Once you got the booking detail, then you actually need to go to the search service, and from the search service you actually need to get the details at what is the current status of the flight. Is this flight currently available? Is it overbooked? It is underbooked? What is the status? You will get that from the search service. Then update the booking, send the request to the booking service to update it, and then based on that you will update your reminders also. Right? So multiple things you might have to do. That's why although we have a very small use case, but if you go to very scaled applications, very big applications, there will be one more layer in between, and you will definitely hear this 100 times, called as orchestrator or the orchestration layer, right? This orchestration layer, what it does is API gateway communicates to the orchestration layer, and it's the duty of the orchestration layer to actually communicate to different services. It's the duty of the orchestration layer. Right? And then these services can communicate in between themselves also. For example, for a booking service, the booking service might have to communicate to the reminder service as well. Because let's say when the booking is done, then the booking service is going to somehow communicate with the reminder service. So there can be a case that these services might have to interact within each other as well, right? Why we are separately introducing orchestrator? Because our API gateway is doing a lot of things. We don't want our data aggregation also to happen there also. You can technically eliminate orchestrator altogether and do everything inside API gateway. And technically that is what we are also going to do. But when you see very big applications, for example, applications like LinkedIn or applications like e-commerce platforms like Flipkart, these very big applications, they don't just interact with 2-3 services. There will be like hundreds of services actually going on behind the scenes. If your API gateway will start handling aggregation of every service, it will be too much. Just think about it. If you see with respect to a Flipkart, now Flipkart might be having some of the servers or some of the services that just purely handles Flipkart flights. Then some of the services might purely handle Flipkart.com's normal e-commerce purchase. So for both of these, you will be having two different orchestrators. For both of these, you will be having two different orchestrators, right? This is why, like, the moment you start introducing more services, you will realize that your API gateway has to do aggregation of Flipkart flights also. Your API gateway has to do aggregation of Flipkart.com's e-commerce purchase also. API gateway has to do aggregation of some admin logics also, those are for the sellers. API gateway might have to also do something for the let's say some other business application. For example, let's say Flipkart starts running something similar to what Zomato or Udaan does, that they do, for example, in bulk, they start taking orders for local vendors and everything. So for that, you will be having data aggregation going on for that also. Now you will realize that your API gateway is having a lot of logic. If your API gateway down, everything is down, right? So what your API gateway actually can do is, your API gateway can be simple. It can act as a reverse proxy, right? It can actually act as your rate limiter. It can actually act as your authentication layer, and then forward the request to a corresponding orchestrator. Sometimes you might don't even need an orchestrator, so you might bypass the request as well. No problem at all, right? Sometimes you might not even need a orchestrator, so you might bypass the request from the orchestrator also. But if there is any kind of data aggregation logic going on, then you need an orchestrator layer as well, right? And for different club of services, there can be different orchestrations. So in our project, we are not going to implement orchestrator, right? We are not going to be implementing this orchestrator, right? We will not implement it. But generally, if you will see very scaled applications which have got extreme amount of features, a lot of services going on, there definitely will be an orchestration layer. Every company that at least at a scale level I have worked, there is an orchestration layer always. When I joined LinkedIn, day zero, I heard the word orchestration service, and I was like, what the hell is an orchestrator? What do you do with an orchestration service? Then I realized that what is the use case of orchestration, right? So this is something that I wanted to notify you prior. For our use case, we just have 3 services that are going to work very closely. So we don't need an orchestration. So we won't implement orchestrator, but there can be an orchestration layer in between that will be doing that will be communicating with multiple services, getting response of one service and then forwarding it to the next service, so on and so forth. Now, of course, these services are also going to interact with each other, right? Now, a lot of time what will happen is when you actually create a booking, of course, you don't want to immediately send an email, right? If I have done the booking, the email can come like 2 minutes from the booking, right? It's not like the moment booking is done, then only email should come up immediately. We can wait for email for like 2 minutes, and generally we have to wait, right? So this reminder service has to do a lot of things. This reminder service has to get details of the booking, what booking has been created, and so on. And based on that, actually has to process a lot of things. So generally, it won't be like you are directly communicating from your booking service to your reminder service. This will not happen, right? This is kind of like an asynchronous operation that we can do without a fail, right? We don't need to be immediately available for an email or for a WhatsApp notification, something like that. This reminder service can be kind of general notification service. From here, you can send emails. From here, you can actually send your WhatsApp messages, whatever you want to do. So what we'll do is we are going to actually place a component. Let me take a different shape. Okay. So we're actually going to place a component that is called as message queues. What will happen is this booking service is actually going to publish a bunch of messages in the message queues, right? This booking service is going to just publish a bunch of messages in the messaging queues. So let me copy, and there can be multiple messaging queues as well. It's not allowing me to copy. Here we go. Right. Let's say there is one more message queue. Right. What this message queues actually does is these message queues are actually going to collect the request from a particular service, right? And keep it with themselves. So this booking service is actually going to publish an event to this message queue. And then this reminder service is actually going to subscribe to these messages from the message queue, right? It will be kind of like a pub sub going on. Pub sub. Right. Why there is a pub sub? Because just think about it. If let's say at any point of time, too many bookings are coming up. And from your booking service, you are directly sending a request to the reminder service. And you have not scaled your reminder service because it was never required, right? It has just to send an email. What will happen? The reminder service can also go down. But reminder service is very chill service, right? It can send an email even after 5 minutes. No problem in that. So what we will do is we are going to publish some events in the message queues. They are going to wait in the message queue. At any point of time when reminder service will be available, when it will be having lesser load, it is going to subscribe to a message. In that message, we will send the detail of what is the booking detail, what is the email that they have to send, whether the notification type is an email notification or a WhatsApp notification, whatever it is going to subscribe to that. And then based on that, it is going to shoot up some emails, right? By doing this, you won't directly put a lot of load on your corresponding reminder service, right? So a similar question to this was asked to me in one of my interviews at Shopee. For example, let's say you have a service, right? And there's a third party service, right? And your current service can actually send 100 QPS, 100 queries per second. But the third party service can only take 10 queries per second. How will you manage this bottleneck? That you are sending a lot of data, but you're not consuming a lot of data, right? So what you can do is you can make your data halt inside these message queues that, okay, this is sending 100 QPS, no worries, let it send 100 QPS. The third party service is actually going to take 10 QPS per second, process 10 messages and then send it back, process 10 messages, then send it back, right? This can be a good way to handle this kind of things. So let's say if at any point of time, you have to do something like this, that every day, on every hour, you have to check that from this particular hour and 48 hours from now, is there a booking for someone and you want to do something, you can actually schedule cron jobs, right? You can actually schedule cron jobs. What are cron jobs? Cron jobs are very simple jobs that you can configure in your operating system. What it does is you can actually set up some scripts that you can run, let's say every hour from now, right? Or every 10 minutes from now, or every third day of a week, or every 10th day of a month. These kind of scheduling you can actually do, right? So you don't need to set up separate timers. It is a operating system level feature that is actually given to you. You can actually read about cron jobs. You can actually read about cron jobs. So cron jobs are scheduled at recurring intervals specified using a format based on Unix cron, right? So you are going to just specify a particular format, and in that format you are going to mention that, okay, this particular piece of code I want to execute every 10 minutes from now or every 30 minutes from now. This kind of a simple scheduling we can actually do that is good enough suitable for our use case, and we can set up a cron job that can actually do a bunch of stuff inside the reminder service. So cron job setting up we are also going to do. In a real life situation, you will also be having a payment service. In a real life situation, there will be some payment service also going on. Now this payment service can be a third party service, or this payment service can be something that you can prepare on your own if you have your own payment gateways and everything. For example, this can be a third party service on Razorpay. We're not going to integrate that because generally it takes a bunch of money and everything, but things are going to be pretty simple. You have to just make a corresponding API calls and everything, right? And generally it makes the overall integration of payment service becomes a bit easy if you have a setup, front end setup as well, that we don't have. So for the sake of simplicity, we are not going to integrate a payment service. We might make a dummy one, or we will just keep a blank there that, okay, this is the moment where you want to go to the payment service, right? But we are going to talk a lot about how to handle payments in a proper way. There are a lot of use cases that can come up when you're actually handling money of a user, right? This is going to be something very important that you need to actually understand. Now you can see how we will be scaling the services, how we can actually scale the services. So for very simplicity, again, it can be dependent on what kind of architecture you want to pick up later and everything. In front of when we will deploy every service, we can actually maintain load balancer of each service. Okay. What will happen is, and we will be doing something called as auto scaling, right? So there will be a load balancer sitting in front of every service. We will just communicate to that particular load balancer, and that load balancer will automatically redirect the request to one of the servers of the corresponding search service. For example, there are 5 servers of search service going on. 4 of them are already busy, one of them is healthy, and we made a request. So the load balancer of the search service will redirect the request to one of the servers, right? So you can maintain load balancer of each service level, right? So that if any particular service has to go to a particular scale, then it can actually do that. A lot of time what people actually do is, like we will talk about that during the deployments. First of all, we have to actually understand how exactly the backend is going to be prepared. I'll talk about more details around the scaling part and deployment part once we start the deployment of this particular application. Now we have already discussed what is going to be a Uber level design for our overall service, right? Or I would say overall services, how many services are going to be there, what will be their roles and responsibilities, right? So the first service that we are going to actually straight away target is going to be our flight search service, where we will be able to not only just create flights, but we will be able to also search flights, right? We can filter them based on multiple criterias, so on and so forth, right? So this project that we used in order to understand basic SQLize and ORM stuff, right? We are going to use the same project structure and directory in order to understand flight service implementation as well, right? Okay. So now if you carefully see that we already had one model with us, that is the airplane model, right? If I go to the models, we already had a airplane model, which is going to represent model number, capacity and all, right? Now let's talk about a bit of things on the design, that how exactly we can actually design this overall airline search service. Okay. So what I'm going to do is, now let's try to think about the design of the database, that how the database is actually going to be designed. A lot of time in system design interviews also, You might be given a very small component of a very big app, and you might be asked to design a particular database, that how the tables and everything should look like as well, right? So what we can say is that we have a airplane table. We have a airplane table, right? Now, when you actually take a flight, for example, you want to go from Delhi to Bombay, right? Mumbai. In that case, it's not like for Delhi to Mumbai, a 6:30 p.m. flight is there. Then there is a reserved aircraft that only goes from Delhi to Mumbai and comes back from Mumbai to Delhi. It's not a case like that, right? The aircraft that actually is used, the airplane that is actually used, can be common in multiple flights. For example, the same airplane can be used from a flight to Delhi to Mumbai, then Mumbai to Chennai, Chennai to Jammu Kashmir, Jammu Kashmir to, let's say, Kolkata, Kolkata to Delhi back, then let's say Delhi to Ahmedabad, then Ahmedabad to Mumbai, and then Mumbai to Delhi. The same airplane can be actually used in multiple routes, right? So when we actually define a flight, then every flight is going to have a unique ID, a flight ID, right? For example, UK808, UK803. These are what, some Vistara flight codes, right? That is a unique flight number, right? Now for a flight number, for a particular flight, we can have an airplane ID, because a flight, or I should say an airplane, might belong to multiple flights, right? To multiple flights, right? Airplane will belong to multiple flights. It's not like airplane is going to just work for a single flight, right? One airplane, one aircraft can be used in multiple flights. So what is the airplane that we are going to use? You can actually have a reference to that. Then you need to actually store departure and the arrival cities. So it would be good to have a separate city table as well, where here you can see departure city and arrival city, and technically city ID, right? Because in case you have to change the city name based on our normalization concepts, we know that you don't need to go to every flight and change it there. You will just make a change in one of the city records and the ID will be updated here, right? As simple as that. Now, every flight will be having some arrival time and will be having some departure time, right? Then every flight will be having some price, right? One flight can have some price, right? Then there can be some boarding gate of a flight. This boarding gate value can be initially null. When the flight is about to take off, let's say 5 hours from now, then generally the boarding gate is updated, or let's say 24 hours or 48 hours from now, then the boarding gate is actually updated. We can also have total number of seats, that how many seats we have in the flight, and so on. So there will be multiple properties that you can actually have in a particular flight, right? That what airplane ID it is actually having. Apart from that, you can also write the airline name, that this flight actually belongs to which airline, right? This flight actually belongs to which airline. Okay. Now, technically, this departure city and arrival city is not the best way to go for. Why? Because in one city, you can have multiple airports. So instead of departure city and departure, arrival city and departure city, let's have departure airport and arrival airport. And let's have a airport table as well. So a city can have many airports. One airport will just belong to one city. And here we are going to store airport ID, because now if we are storing airport ID and airport ID belongs to a city, so just by using the airport ID, we will be able to get the city also, that this flight is going from which city to which city, right? We don't have to bother a lot about the fact that, okay, this is not going to come up from some particular place, right? So these 4 or 5 tables, at least in the initials, I'm able to at least see that looks good to me. Maybe during the development, we might feel that a few more changes might need to be done. So we can do changes based on that. But first of all, what we are going to do, we already have our airplane model. Let's prepare the whole CRUD for the airplane model. We already have it, right? Then let's prepare a bunch of CRUD APIs for city and the airport model, because this is pretty straightforward. People can actually just add a bunch of cities, and technically for city, you don't even need CRUD. City can be handled using what? Maybe seeds, right? Because once you update, once you add the cities, then it's done and dusted. But still, we are going to build a bunch of REST APIs, which will be the CRUD REST APIs, but you can still handle it with seeds if you don't want to like redundantly, right? A lot of things are going to be redundant. Same thing for airport, right? In the airport also, the airport will be having, let's say, an airport name. There will be some address of the airport. It will belong to some city and so on, right? So new airports can get added. Whenever we will be adding a flight, we need to have information of the airport. So all of these things we will require. So we will spend some time in actually setting up these three, which are very simple models. These are very simple. There's no complexity at all. If you are able to understand everything around the airplanes create API, everything rest is going to be a bit redundant until or unless we reach the flights table altogether, where we will talk about more things about the sequelize capabilities. Now, till now, we just have one API, that is /airplanes, right? Which is going to create airplane, which is a post request, right? Now let's write a few more. So if you go to your airplane repository, we don't have much of an information because we are just directly getting our CRUD repository. Inside our CRUD repository, we refactored our create function for that error handling mechanism. Maybe we can actually do that here as well, right? So I'll remove the try catch and make it a bit more clean. Same thing here, I'll remove these try catch, because in service we will be already handling a bunch of stuff, so we don't need to care a lot. And looks good, right? So we have removed try catch from everywhere, because now the error handling, logical error handling, we will do in the airplane service file. Now let's try to see what all data we have in our database, right? So what I'll do is I'll open the MySQL console here. Okay. Okay. Show databases. Okay, and we have a flights database. Use flights, show tables. You can see we have an airplanes table. Select star from airplanes. Okay, you can see a bunch of things are there. Now I'm not that happy currently with our model, right? Because I'm going to again make a change to it, right? You can see currently there can be multiple entries of an airplane, right? And to be very honest, there can be multiple entries of an airplane, right? uh, that is going to be here, but I believe later in some time we should or I believe currently we have this id property, right? This id property is there. So what can happen is, for example, Vistara can have 5 Airbus A380. It can be there, right? There can be 5 Airbus A380. All 5 will be unique based on this id. So even this current situation is good. If you will require any update, we will do, right? You can see capacity validations and everything is there. So this looks good. Okay, we don't have much of a data here. We don't have much data here, right? So maybe we would like to add up some data. So let's do one thing. Okay, we have our seeds prepared, I believe, right? You can see we have some seeds prepared. Let's have some seeded things seeded here. npx sequelize db seed all. And you can see now details have been seeded, and you can see now there are more data actually present here. Okay, good. This looks good. Now let's say I want to write an API. Again, now things are going to be again pretty redundant. You just need to focus on our repository layer and the controller and the service. Okay, and because there is not much business logic in a basic CRUD, so we'll be having pretty straightforward functions. I'll write a async function, get airplanes. This function is going to get me all the available airplanes. Try catch. Okay, I'll say const airplanes is equals to await airplane repository dot get all. Right, there's a function in our CRUD repository called as the get all function. This just applies the model dot find all, nothing more, nothing less, right? And that's it. We'll say return airplanes. Okay, and apart from that, what can happen? Maybe something went wrong, right? Now there won't be any validation error or anything that can happen. So from here, I'll just say the most probable errors that can occur is maybe we were not able to connect to Sequelize or something. So we'll say cannot fetch data of all the airplanes. Okay, cannot fetch data of all the airplanes, right? Let's say this is going to be there, this is going to be there. And we have a get airplanes with us. Okay, very simple stuff. We are not doing anything fancy. I'll do module.export. So see, I just wrote a service function, get airplanes, and did a module.export. Nothing more, nothing less. I'll come to my controller. I'll say async function, get airplanes, request comma response, right? And then we can say try catch again. Okay, we'll just copy paste this, nothing much. If whatever is the error object returned by our service, we will attach that, and inside the error object we will be having a status code also, so no problem. And here we'll say const airplanes is equals to await airplane service dot get airplanes. Very simple stuff, no fancy things at all. Success response dot data is equals to airplanes, and then we are going to just return this. And now the status code that I'm going to return is okay, because now we are not creating anything on the server, right? We are just fetching the data. So I'll say response status code is status code dot okay. Dot JSON is the success response that we prepared a common success response. And inside the data property of the common success response, I have added the airplanes. As simple as that. Copy, paste, get airplanes, right? And then we'll go to v1 routes. Now, if somebody goes for /API /v1/airplanes on a post request, you will create an airplane. But if somebody goes for a get request, right? If you remember the REST conventions, a get request on /API /v1/airplanes, where we don't need any middleware, you should be able to get all possible airplanes. So I'll say airplane controller dot get airplanes. As simple as that, right? Now let's run our server. npm run dev. Okay, everything started, looks cool. Let me open Postman. Now we have our Postman open in front of us. Let's make a get request here, right? If you make a get request, send, you can see all of the airplanes we are able to get, no problem at all, right? So we have successfully implemented our get all airplanes API, right? So I'll do one thing. I'll say get add all, git commit -m, added get all airplanes API, git push. That's it. As simple as that. So with a bunch of changes, we are able to actually implement our get all airplanes API. Now currently we are able to get all of the airplanes. Let's do something even simpler. Okay. So if you remember, in our CRUD repository, I have a function get, which is going to technically take a primary key. See, we are using a find by pk function. So that means this data should be a primary key. So what I can do is, I can say inside my service, I can write a async function get airplane, which is going to get a ID, airplane ID. I'll copy everything from get airplanes. And from here, I'll call the function dot get and pass this ID, as simple as that. Right? Then I will just return get airplane. I'll go to controller. I'll copy everything from get airplanes. I'll rename it to get airplane. The service function also I will rename to get airplane. Here you can see get airplane. And now it needs an argument. So I will say request dot params dot id. Why? Because let me write the API structure here. This API structure is going to be slash airplanes slash colon ID. So inside our URL, we are going to have an ID property. How do we access it? We can say request dot params dot id. Okay. And we don't need anything in the request body. We don't need anything in the request body, right? The get all airplanes was not even having an ID. It was just slash airplanes, right? So now we will pass request.params.id. Why params? Because this is a URL param input that we are actually sending. Okay. So we'll say get airplane, right? Okay. And let's go to routes. Here, I'll just copy this route. See, very simple stuff we are going to do. We'll copy the route and now we will just say we want something for colon ID, right? So I'll just say slash colon ID. So if somebody will ask for slash API slash v1 slash airplane slash colon ID, we will be able to send it. Okay. There are a few checks that we have to put. Also airplane controller dot get airplane. So see, we have this get airplane. This is the new function. Inside it, we have service dot get airplane. We have this new function. There are a few error handling that we have to do, but we'll wait for it for a moment. You can see server restarted. And now if I give slash airplane slash one, if you see carefully, slash airplane slash one and send it, you can see now I'm getting a single airplane. So if you just have to get one airplane detail, you will be able to just very easily get that. But what if I do slash 100? Now there is no airplane with the ID 100, right? There is no airplane with ID 100. If you send it, doesn't look good. Why? Because data is null. It says success 200. Okay, this is definitely not what we want. We should technically say 404 not found, right? That we are not able to find this resource. Can I say that? So what I can do here is, let's say I can go to CRUD repository. In the CRUD repository, we can say if not response, that means we were not able to find a response, then I'm going to throw some error, right? We can actually throw some error from here, right? And you can actually throw new, and like technically let's think about it. We need to add a message, right? So let's not do it here. Let's keep it consistent. Let's do it in the service only, right? That is if not airplanes. Okay. And this should, let's rename it to airplane because we always will get one airplane. Okay. If not airplane, then what will happen? Also, when you actually make a query to find by pk, it doesn't return you an array. If you remember, it doesn't return you an array. It will just return you an object, right? So you can actually check whether that object is null or not. If it is, then you can actually throw new, and let's see what will be the best way to handle. We already have a catch here, right? Let's handle it in CRUD, because this can be common. This can be common, right? Because let's say if we are doing city and we were not able to find a city, it should be common, right? So it's a common piece of code. Let's write it here. If not response, then I'm going to throw a new error, right? So throw new. Now we have app error with us. We are going to throw an app error, right? Not able to find the resource, and we are going to set a status code. Const status codes is equals to require HTTP status codes. Okay, and I will say status codes dot not found. Okay, as simple as that. And this app error is going to be caught on the service layer. So here I can say if error dot status code, you remember, right? This error can have a status code property because we are coming from app error file. Remember, this is a status code property. If this status code is actually equals to status codes dot not found, then from here we can actually throw a proper error. Throw new app error. The airplane you requested is not present. Or you can say, yeah, airplane you requested is not present. Okay, this can be open-ended, like what messaging you want to show. And the same status code I will just return from here, error.status code. Okay. Otherwise, if there is anything else that happened, for example, SQLize was not able to connect or something, I don't want to show that to the end user, I'll just say internal server error. Okay. And then if you go to the controller, in the controller, everything is already handled. If the service is throwing an error, you'll just consume that error. No problem at all. Let's see if the server is running. Yes, the server is running. Let's send the request again. Send. Now this time you're getting 404 not found. Success false. Something went wrong. The airplane you requested is not present. As simple as that. Right? So pretty cool stuff we are able to do. And if you will give some valid airplane ID, you can see now you're able to fetch the airplane properly. So we have successfully implemented one more API, that is get airplane API. I'll just quickly commit this. I'm committing this so that you guys have always time-stamped progress and milestones on the project. Added get airplane API. That looks cool. Now one more API we will write is for delete. And if you see for CRUD repo, we have a destroy function in the CRUD repo. Very simply, we will be able to do so async function destroy airplane. You will get an airplane ID to destroy, as simple as that. And I'll again copy paste everything from here, or let's copy paste from get airplanes, this one. Here I'll say const response and I'll say return response. Okay. And I'll this time say airplane repository dot destroy. So see what's going on. In the service, we wrote a function destroy airplane. It will take an ID property. I'll put a bunch of try catch. Const response is equals to await repository dot destroy and just pass the primary key. Here, based on the primary key, you are actually going to destroy your corresponding object, right? As simple as that. Let's say destroy airplane. Very good. Controller, let's come back to controller and I'll just copy paste everything from here. Paste it here. Now the type of the request should be a delete request and the URL will be /airplane/:ID and I'll say destroy airplane from request.params.id. Okay, request.params.id. As simple as that. We'll export destroy airplane, export it, right? And we'll go to routes, copy this. I'll just paste it here. Now, if it is a delete request, then we can do airplane controller dot destroy airplane. As simple as that. Let's see if the server is running. Yes, the server is still up. Now let's say I want to delete the 6th airplane. So I'll change the request to delete here and make a request, send. Successfully completed the request, right? 200. Okay, now we have successfully deleted it. And if you actually go to MySQL to select star, you can see the 6th airplane is gone. But what if you do 600? This airplane doesn't exist, right? Let's see what happens. If you send it, you can see it still successfully completed the request. But the difference is in this data property. If you try to delete something which is not present, my SQLize actually returns you 0. And if you try to delete something which is present, for example, let me delete the 7th record, then it sends you 1. Based on this, you can actually do your error messaging, right? Based on this, you can actually do your error messaging that the resource that you are trying to delete is actually not present. So I'll again just do the similar stuff. I'll go to CRUD repository, right? And if not response, that means response is false. I'll try to throw this error. Not able to find the resource, not found. Okay. And then I'll go to service. Same type of error handling, just like the above function. If status code is status code dot not found, the airplane you requested to delete is not present, and that's it. Now let's try to delete something which is now not present. See, the airplane you requested to delete is not present, right? So now even delete we are able to validate. Okay. Now a lot of time you might feel that, okay, we need some middlewares for this. No, we don't need middlewares because we don't have to validate any request body, because we don't have to validate this ID, right? If somebody will not pass this ID, then technically the route is not even present. For example, if you go to routes, if somebody makes a delete request to /airplanes, they don't pass the ID, right? So there is no route registered for it, right? For example, if you try to make a request to /airplanes with a delete request, send, you can see nothing will actually break. So you don't need to validate. Once, like if you are working with some other type of databases, for example, Mongo. Now in Mongo, there can be a good validation you can actually put. If you don't know about Mongo for the timing, so don't worry. But Mongo is a NoSQL database. Mongo doesn't give you incremental IDs like 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it gives you kind of like a hashed ID, which is a very long ID. So you can actually put a middleware saying that whether it's a valid MongoDB ID or not, because somebody can just pass random ID, random hash, and still the request will come in the inflow of your controller, then service, then repository, and in the repository you will realize it's not present. So you can actually validate that in the middleware and stop the remaining calls, that this is not even a valid Mongo ID, so don't move forward with the request. But we don't have to do that in MySQL because MySQL is going to allocate you ID in incremental fashion. Now let's quickly commit git add all, git commit -m, added, delete airplane API. As simple as that. Now here's going to be a takeaway task for you, right? What is a takeaway task? Maybe I can create a ticket here, issues, right? A lot of time you will see people writing issues and everything, which technically correspond to what are the pending tasks. So I can create a new issue, right? Implement, this can act as your assignment, right? implement update airplane API. Okay, I'll write a detail. We need to implement update airplane API with the following signature. With the following signature. What's the signature? Slash API slash v1 slash airplane. Okay. And let's write it like this, which is going to be what? Let's say a patch request. Okay. We'll make a patch request. We might want to make a partial update to the plane. Maybe let's say we want to increase the capacity of the plane or something. Okay. And the request body will actually look like what value you want to update. Let's say capacity with 250, something like this. Okay. Okay. And yep, do handle the error scenario as well when we don't find a record to update. Okay. Submit new issue. You can see now this is something that you can actually pick up. Whatever our takeaway task, I'm going to create an issue for that, so you can actually track what you have done, what you have not done. Right. So again, this is going to be a fairly simple implementation. You just have to take a look at the other implementation and write an update one. Maybe try to figure out what are the functions here. Although I already have a function in the CRUD repo, but still it will be a good figuring out task for you. Now we have technically completed a complete REST API for our one of the CRUD, or I would say one of the resource. Let's add one more resource. Okay, now I want to add a city resource. Okay, so I'll stop the server. Now if we want to add a city resource, that means there will be a city table. If there will be a city table, that means we need to create some migrations, right? So what I'll do, npx sequelize model generate minus minus name city minus minus attributes. Okay, and what attribute you want to keep in a city? A city will be having, let's say, just a name, nothing much, name that will be of type string. I just want to keep a very simple thing, like not even a fight. Okay, let's press enter and make sure you like write all the properties. Let's press enter, and very simply we have got a new model and a new migration. Let's take a look at it. So we have a city.js model. Let's add some validation here. Every city should be having a name. So let's say okay. So I'll say allow null to be false. Okay. Right. Okay. Now two cities should not have a same name, right? There cannot be a case that two cities have a same name. Two different airplanes can have a same airplane model. For example, my iPhone and somebody else's iPhone, both can be iPhone 14 Pro. But we'll be having different iPhone serial ID, right? But two cities cannot have different, same names, right? At least when we compare a city to be having an airport kind of a thing. Otherwise, just think about it. If you have a city with a corresponding name and there is another city with the same name, you are going to route yourself somewhere else. And that's going to be pretty bad. Pretty bad. Right? Okay. Now, let's do one thing. Let's open Google and let's see what Sequelize offers for us for uniqueness. Okay. Let's see. Sequelize unique. Okay. Something like this. Let's write Sequelize unique. Okay. Let's see what does it give us. See, there is a property unique true. As simple as that, right? So you can say unique true. Unique true. Okay. And that's it. Same validations I am going to put inside my migration. So I'll just copy from here, paste it here. It will be just sequelize.string. Okay, only difference will be there. So sequelize.string is the type, allow null false, and unique true. Okay, this looks good to me. Let's close it. And now we can do npx sequelize db migrate. The moment I press enter, okay, we migrated the db. If now I do show tables, I have a cities table. If I describe cities, you can see there is a name property, id is a primary key, name is always unique. So you can see this unique key means it's always going to be a unique, right? So this is going to be pretty cool. Okay. And once we have the model in place, now we can do a lot of stuff with it. So I'll make a different commit here. Git add all, git commit minus. Okay, I'll just do git commit. I'll not do -m because for your help, so that you guys can do it actually, I'll copy this command and I'm going to paste this command in the commit message. So added a new city model using the following commands. Okay. And let's say it like this, added. So, right. So that when you guys will be doing it at home, you guys can just directly execute the command so that you have it for reference. Escape :wq. And the commit has been made, git push, right? So if you will go to GitHub, if you will go for the last commit, you go to the commit details, you can see, you will be able to see what was the command that I actually executed. As simple as that, right? So pretty cool stuff, right? Generally, if you go to flight applications, then for a city like Kuala Lumpur, every city has a unique code, KUL, BLR, right? And the same code is also written on your boarding pass as well, right? DEL for Delhi, right? There will be something for, let's say, Heathrow Airport, something for New York Airport, something for everywhere, right? And technically, this can be airport dependent as well. Do you think? Let's see. Let's confirm it. Flipkart flights. Now, in as far as I know, in UP, I guess there are multiple airports, right? Let's check it out. So from Bangalore, so you can see BLR is there. Let's see what you have for Uttar Pradesh. Uttar Pradesh. Let's Google Uttar Pradesh airports. Okay, there can be multiple airports. There is a Gorakhpur airport, I guess. Kanpur airport. So it's a military airport. I don't want to go to a military airport. These are airstrips, I guess. This is the one for Varanasi, right? Lal Bahadur Shastri International Airport. So you can see the Gorakhpur airport has a proper coding, right? That is GOP. And then this airport is having a proper coding VNS, right? So there, like a city can have many airports, right? And every airport will be not just having its just name and its city, but we also need to keep in mind that in one city there can be multiple airports. So every airport is going to have this unique code. I'm not sure what is for. There is a Noida airport nowadays as well. I don't think it has got a code because I'm not sure if it is running, right? But it will be soon. For example, if you go for New Delhi airport, right? And you can even check it here. If you go for Delhi, you will get DL. But let's say if you go for London, in London there are multiple airports. Now you can see every airport has a different encoding. everything is London GB, London GB, London GB, but this LHR is the Heathrow airport. Okay. Then if you go for London, LON, this is all airports. So if you want to refer to all airports of London, you are going to have one encoding, right? If this is also that they have handled, right? London, and let's say LCY is the London City Airport. So there are multiple airports, there can be multi airports. So when we will make our airport model, we have to keep this in mind that we have a unique encoding for every airport, right? A lot of time you will feel that, sir, we already have a unique ID that will be the airport ID, the primary key. Can we not use it? We can use it, but we need to send some data to the front end also, right? On front end, you can't say London 1, London 2, London 3, London 4. It will be a better user interface to maintain a unique encoding for everything as well. Now, writing CRUD APIs is going to be pretty simple. First of all, I'll prepare a repository. I'll create a new file, city repository.js. I'll copy everything from my airplane repository because it's going to be a simple CRUD. There is no logic, anything, so we don't need extra database functions. I'll just take my model, city model, right? This will be called as city repository. I'll export city repository and I'll pass the city model to our constructor. That's it. So now we have a repository layer. If you want to add some extra functions, you can, but I believe it looks cool, right? Pretty cool. So once we have our repository with us, now is the time to create a service. New file, same stuff again, city service.js. Okay, absolutely no brainer at all. You go to airplane service, you can see what all things you need. So I'll copy these basic stuff, paste it here. So I got the status codes. I'll get the city repository. So I need to export the city repository from repository. So see, here we have an index file, right? I need to export the city repository. City repository. Okay. Now here we will import city repository. App error we will get, and we will here say city repository is equals to new city repository. As simple as that. Module dot exports, and let's try to have some action. First of all, I'll write an asynchronous function, create city. Okay, create city. It will get me a data property. Okay, I'll export this create city function. Okay, now I'll go to airline service, and mostly it's going to be a copy paste. Mostly it's going to be a copy paste. I'll copy paste everything from create airplane to create city and make all the changes. For example, I don't have an airplane repository. Here we have a city repository. This is going to create a city for me. So the response variable will be city. If there will be any validation error or something, we just want to keep it like this. And this should be a new city object. That's it. You can see pretty redundant stuff. So for basic CRUD API making, you can see all you have to do is pretty redundant stuff. You don't have to put anything from here. Okay. And that's it. Now time to create a controller. New file, city controller.js. Let's go to airplane controller. Let's get some this initials headers. So now I need airplane city service, right? So here is the city service. Let's export city service. City service require, right? So till the time we go to actually the flights database, not much of a things are going to come up. So it will be pretty redundant stuff. Now you can get city service. Okay. Now again, I'll do copy paste. I'll go to create airplane function, copy this, paste it here. This time it will be a post request for cities, right? See, It's previously for airplanes. Now it will be for cities. Okay. Request body will be like this. I just will be getting a name. London. Okay. And I'll say create city. As simple as that. Now I have a city service, not an airplane service. So city service, right? See, here we had a airplane service. Now here we will be having a city service. City service dot create city. Now you don't need to send this. You just can say name is request dot body dot name. Pretty simple stuff. Response variable will be city, of course, and success response dot data will be city. As simple as that. And you will say module dot exports create city. As simple as that. So now you can see your controller is also ready, right? Now let's go to v1 routes. Let's create a new file, city routes.js. Okay. Just like airplane routes, we can have a bunch of city routes. I'll copy paste everything. We don't have these routes, so I'll remove it. Okay. Now, first of all, I need to export the city controller. So city controller, city controller. Let's come to routes. Let's get a city controller. Okay. Then I don't have a middleware setup currently. I'll do it in a moment. Now, if anyone will make a request to /API/v1/city with a post request, I'll say city controller dot create city. As simple as that. Okay. And we need to register this router, right? We need to actually register this router. We don't need this middleware. Currently, I don't have middleware. See, I registered the airplanes router. Let's register the /cities router. So I'll say const city routes, city routes, and we'll say city routes. As simple as that, right? So now if somebody will make a request to this, it should be able to create a city. Let's go. So let's see, the server is running. No, server is not running. Let's run the server. npm run dev. Good, server is up. Let's make /cities. Let's make a post request. In the request body, you can send a name, and let's say name of the city can be Bangalore or Bengaluru. Okay, Bengaluru. Let's send the request. If you send it, boom, Bengaluru is created, right? So our create API is actually working. Let's add one more. Mumbai. Mumbai is created. New Delhi. New Delhi is created. What else? Indore. Indore is created. Varanasi. Varanasi is created. Okay. Let me do one thing. Let's say Varanasi is already created. Let's try to create Varanasi again. And if you remember, in my model, I have a unique constraint that city name will be unique. So if you send it, something went wrong. Cannot create a new city, 500 internal server error. Okay. So now this can be an opinionated thing, that if somebody is actually trying to send a city which is already created, do you want to give them some meaningful information or not? Right. Let's say we want to send some meaningful information. Okay. Let's see what can be a good error code to handle. So you can actually Google. I'll Google it in front of you. What error code to return in case of duplicate entry error. Okay. There is something like 409. Let's see. MDN status code. Let's see what is 409. Conflict. The response is sent when a request conflicts with the current state of the server. And this looks good. Like the current state of the server already has an entry and you are trying to duplicate it. So 409 is something that they are suggesting. Okay. Let's see if anything else. You can also send 400. Let's see what's the question. I'm building an application with REST based API and I've come to a point where I'm specifying status codes for each request. What status code should I send for request failing validation or request is trying to add a duplicate in my database? Okay. And they said, I have looked through this protocol, but none of them seems right. So what people are referring for input validation, 400 bad request plus your optional description is good. This is suggested in the book RESTful Web Services. Update June 2014. The relevant specification used to be RFC 2616, which gave use of 400 bad request rather narrowly as the request could not be understood by the server due to malformed syntax. So it might have been argued that it was inappropriate for semantic errors, but not anymore since June 2014. The relevant standard RFC 7231. So these are actually REST standards and everything. You can actually open it. I'll show you. Which supersedes the previous one, gives 400 bad request more broadly as the server cannot or will not process the request due to something that is perceived to be a client error. Okay. So these are all the, I would say, documentation and references. You can actually go and one by one try to read it. But again, you don't need to go through all of this. You will just easily Google it and you will get it. So I believe 400 bad request we can actually give in case there is a duplicate entry. Okay. So let's try to handle it. First of all, let's see what is the error that we are getting. So I'll go to my service. Okay. Let's console.log the error. Let's see what error my ORM is throwing. Let's send it. This is the error. Duplicate entry Varanasi. And the error is what? Error is a sequelize unique constraint error. So we can handle it. Okay. So we can say that if error.name is equals to sequelize unique constraint error. Okay. Now let's read this error object. It again has an errors array. See, errors array is there. Okay. And again, similar stuff that we used to get for validation error. So technically we can club them. It looks like we can club them. So we can say or this. Okay. So I have clubbed both of the errors and we are going to send same bad request. Let's see. If I send the request again, 400 bad request, and because the error object structure is same for two similar validation error, because even if you violate the uniqueness error, it's violating the validation error. You can see we are able to pretty much handle it because the structure is same. We'll just iterate through it and get our error message. And here you can see explanation. Now it says must be unique. Right. Now what must be unique? Now this is something that we are not able to get right. What must be unique? So it would be good if we can take a value, right? That this path name must be unique. Okay. So what you can do is let's update our error message here that error.path plus error.message. And we can even put a space in between. Right? So it will now say like name should be unique, something like that. See, oh, it was already giving name must be unique. Oh, my bad. It was already giving. I guess I read it wrong. Name must be unique. Yeah. So there is only one name property, right? So name must be unique. It's good. It's good. I guess previous implementation is good. Okay. And that's it. You can see very easily. I just added validation constraint here that can actually come up for create city. and this should be a pretty good implementation to go for. If anything else happens, for example, let's say you are not able to connect to database or something, then internal server error is already handled. So this looks good. Let me just quickly commit this. Git add all, git commit -m, added create city API, hit push. Okay. And before we actually move forward, one thing is still left, that is request validation. What if somebody doesn't even give a name? Although we are still already handling it, you can see our backend code in the service layer is pretty robust. It says city.name cannot be null, and it says 400 bad request, right? But we technically don't even want it to go to the controller, then go to the service, then make a call to the repository, then get an error from the repository, throw the error to the service handles that error and throws it to the controller, and then controller sends it. We can actually handle it in a middleware, right? Let's quickly add it. Same thing, city middleware.js. I'll copy everything from airplane middleware, paste it here. And now we don't need request.body.model number. We just need name. Something went wrong while creating city. And the error is city name not found in the incoming request. That's it. Okay. Validate create request. Cool. Now let's export this city middlewares. And in the routes, let's get it. Middlewares, right? And we'll say city middlewares. And here we will register city middlewares dot validate create request. As simple as that. Let's see if the server is running. Yep, server is up. If you send the request now, you can see better handling now, because we are not even going to the controller and everything. But we have made our services and everything pretty robust that even if you miss a middleware, we are still getting good client side messaging. So this can be quickly committed. And that's it. Also, if you will just carefully see, every file that I write, for example, this routes file, or you see this repository, or if you see my middlewares, right? Or if you see my controllers, every controller that you see, you will see the usage of single quotes. I am keeping very consistent. A lot of time you will see people in the same file using double quotes, sometimes using single quotes, sometimes using something else, and so on. Technically, you should try to keep your quotes consistent. It looks clean. It gives an understanding that you are conscious about when you write the code, right? And at any point of time, if you need templated strings, then you can use backtick. That's okay. But don't mix and match a lot on single quotes and double quotes. Just a clean code advice that I wanted to give. Now we have added our create city API. There will be a few more tasks that you have to do. Implement delete city API. Okay. And I'll get the issue description from here. Slash cities. It should be a delete request. Request body should be empty. And you're going to say slash colon ID. There will be a city ID. Okay. Do handle the error scenario when we don't find a record. Okay. This is going to be something that you have to implement. So there is another issue. I'll create another issue. update city API. Let's say a patch request. Let's say sometimes your government can say from today Allahabad is Prayagraj. So your city name can actually change. Okay. Update. Okay. Cool. Submit new issue. Let's see all the issues. I guess in the delete one, I have one thing I need to correct. Edit. Delete. And this should be city API, right? Delete city API. Here also. Update city API. Okay. So these are few that you guys need to make. I will be working on the get city API where we will be actually getting the city details. We'll talk about one more query of SQLize, because why I am keeping these basic models. Now you might be feeling that, okay, sir, this is becoming redundant. Why you are still teaching? And there will be one airport model also. These models I'm creating so that we can get better hang of multiple properties of SQLize. Right. For example, we learned something like unique today. Right. So more SQLize features with these basic implementation will be very easy to understand, because when the business logic is complex, we don't want to actually understand basic SQLize stuff. So I will be implementing few things around get city that will, I'll add a few details there that will help us to learn something new in the ORM SQLize as well. But for the timing, these are the three take home tasks for you till the milestone where we have actually set up our create city API.